There we go. All right. So let's talk about module 1, introduction, and a little bit of AWS's history. So as you're aware, we're going to talk about the history. We are going to talk about AWS's global infrastructure. You probably know this already, but I'm going to add a few things in there that you may not know. And then, of course, navigating the management console, which it sounds like you all are pretty familiar with. So we'll make sure that that's just reviewed. So the history of AWS is a sordid one because obviously it's tightly coupled with Amazon to a certain degree, because they're still a strong subsidiary in a sense. The main thing to note is that in 2006 is actually when AWS launched, and the first service was not S3, it was actually SQS. I was actually tracking them at that point in time. SQS, the simple queuing service, which is really just in its raw sense, just a non-standard messaging bus, works really well, was the first service, along with S3, the simple storage service, which I consider S3 in a sense to be kind of like the gateway drug that hooks everybody else into other AWS services. Because once you start copying a few files up to S3, the next thing you know, you're starting a few virtual machines, you've got some Lambdas going, and the sky's the limit from there. But 2006 is when it was first launched. EC2, the virtual machine service, was a fast follower onto that. I want to say it was 2007, 2008, late 2007, 2008 when it came out. It might have been sooner. My mind is fuzzy for 15 years ago. So the thing to note here, though, is that cloud probably hit its stride in terms of maturity and actually really being able to do things well, probably around the 2010, 2011 timeframe from my perspective. That's when I went pretty much and fully adopted it as my default platform. Because the other thing is that fully software-defined infrastructure that's self-provisioning, which is what AWS pretty much is, enabled DevOps to come to life. Because you were not going to get to full automation if you were running cables underneath the floor, right? And you might say, well, someone's still running cables underneath the floor. That's true. But the economics of AWS means they're doing it so far ahead of when customers actually need it that it doesn't typically become a hardware boundary when we're doing automation. So cloud is now 15 years old. So every single startup that I consult with one notable exception, just because they had a security requirement, is all in on cloud. Every single proof of concept, every VC investor who approaches me and wants to test an idea, it goes in the cloud. Now, most of the time it's AWS. Sometimes it's Google. Sometimes it's Azure, right? Sometimes it's even Oracle's cloud, which actually isn't horrible. I won't say that in public, and I'll deny it if you actually ask me to say it out in public. But just to say this is that cloud has been around for a while, and it's now the de facto way in which we actually approach infrastructure for the vast majority of companies. So, that's great, right? But, because it has, in a sense, changed the landscape. The rest of this in terms of like when Echo was launched in Prime and all that other stuff, that's all just Amazon stuff in general. But really, the main thing to know today is that I believe that Amazon is up to 6,000 deploys a day, of which they guesstimate that 20% to 30% are actually feature releases. Now, not all of those are actually available to the public. Sometimes they're testing them ahead of time, but they're doing 6,000 deploys a day across their infrastructure, which the only thing that makes me think of is like, why aren't they down more? Well, that's because they have their testing and their stuff down, and they're able to hide failure quite a bit. So anyway, that's the kind of like my brief sordid history of AWS. I would say now, by the way, they started out with those two services in 2006. I think they're up to 189, 190 services as of last week. And I mean macro services, not microservices in a like service sense in the console. Meaning you can click on CloudWatch, which is the metrics repository, and there's 11 sub-services inside of CloudWatch, ranging from synthetics to dashboards to metrics, etc. So just know that while there's 189, 190 or so different macro services, some of them like Systems Manager or CloudWatch have a ridiculous number of sub-services underneath them. So, AWS is basically software-defined infrastructure. It started out as infrastructure as a service, started adding some PaaS and some SaaS, and now what we've got is we've got a little bit of infrastructure as a service, and we've got a boatload of platform and software as a service that's available for use. That number of deploys, by the way, as you can see there, as far as AWS's pace of innovation, has tripled in the last 3 years. So they're actually their rate of change is actually getting faster. Their delta there. Total new services and features, 6,162. I believe that's closer to almost 20,000 now, actually. AWS's customers are wide and varied. Obviously, you're a customer. I'm a customer. I just talked about a bunch of startups being a customer. There are other, obviously, cloud providers out there. None of them really have the market share that AWS has, which isn't necessarily anything other than necessarily an adoption and a popularity contest. But it does actually speak to the fact that AWS does seem to be able to solve a broad swath of customer problems. Competition between the other two cloud providers is fierce, but only in a mindshare space. Revenue-wise, AWS tends to blow the others away. AWS does talk about the advantages of using cloud computing, which, just the general issue of operational offloading, being able to, go faster, go global in minutes, the ability to be very agile and innovate, being able to focus less on being good at running infrastructure and more on what's differentiating for your business. Those are important kind of things to focus on. We run servers to enable the hosting of software, but that hosting of software is actually the end goal. There are ways to shortcut that, either by hosting smaller servers or leaner servers or putting automation and scaling around those servers, or in a sense, removing servers altogether, which, even with containers, by the way, that's not going to happen. One thing to make very clear, since I am very much a, hold on 1 second. So I am very sorry. I have a 13-year-old and a 15-year-old running around, so making sure no arms were cut off. Since I am very much a containerization Kubernetes expert, at least a continual learner or student of that, one thing to note is that using containers does not get you away from virtual machines unless you use a managed service like AWS or Azure or whatnot. So just note that AWS's goal isn't necessarily, to be clear, is certainly not to put anybody out of work, but to actually allow the resources that are there in a company to focus more and more on the end goal of delivering software and less about all the headaches and entanglements that can happen when you, for example, you're having to deal with base and core infrastructure. And I've actually had many conversations with them about this. One cool thing also about using someone else's infrastructure that is always growing from economies of scale is that, you can actually guess badly and not really cost the company money. Back way back when I was first getting started in the first .com bubble, I remember the CTO coming to me and saying, "Hey, we want to buy $100,000 worth of servers, brand new startup." And I didn't really question it or really do anything around it. And of course, this predates the age of cloud. And that was one of the contributors that probably helped put that company out of business from a VC standpoint. And at the time, I didn't have either the experience or really the position to kind of challenge that whole thing. But that kind of thing wouldn't happen now, because if we bought a bunch of AWS virtual machines and we didn't need them anymore, we would just give them back, right? Because we wouldn't necessarily go reserved or some other commitment on that. And so you wouldn't actually run into those kind of scenarios now where you made an initial hardware investment and you found out that you didn't need it and you couldn't give it back. And so that's the great thing here also, is that it isn't that you have to stop guessing capacity. It means you can now correct your guesses around capacity, whether you went over or under on capacity. And the other thing is that you're trading deprecated capital expenditure, over that's being deprecated over a couple of years for variable expense. If I was Amazon, I don't know that I would necessarily tout that, because it is actually true that you don't have to do these large capital outlays on a periodic basis in order to maintain your data center. But the variable cost thing can sometimes really shoot people in the foot when it comes to the AWS bill. But it does actually soften the blow of not having to outlay millions of dollars every 3 to 5 years for hardware refreshes. Let's see, just a quick plug that, AWS is in the upper right-hand side. They've been there for quite a while. I think Google's caught up a little closer with Microsoft, and I think Microsoft has gotten a little closer to AWS. But according to Gartner, they're still considered the predominant leader. So just know that Amazon, in a sense, kind of operates like a buffet, and that they pretty much have, what you're looking for. You heard me joke earlier that we're not going to cover quantum computing, we're not going to cover, augmented reality. But I mean, if you're looking for like the Kubernetes, for example, there's an Elastic Kubernetes service. I was joking earlier. If you're looking for Kafka, they've got a managed Kafka service. You look at services for if you want to run their hardware in your data center, they've got outposts. So you can literally run their servers in your data center, and it just acts like an extension of the AWS infrastructure. Or you can cut it off and just run it localized if you want to. So, there's a service for everything, but particularly the foundational services are available. Oh, sorry, I didn't realize that was building. So because of that, there can be an overwhelming amount of services out there to look at. But basically, this is, you probably know this just from the console, is that you can just go out there and search for what you want. So if, we go out there and just take a quick look at the console itself, if I want to do something with quantum computing, well, I just start typing quantum and there it is. If I'm like, I really need a ground station for my satellite management, right? Well, there you go. You can set that up with ground station. If I'd really like to do AMI building of some type, well, you can actually quickly find the EC2 image builder, which kind of like Packer will build a process for building images. So just know that whatever you're looking for, go take a gander. It's probably out there, and it's probably a subservice of another service like EC2, for example. Now, infrastructure-wise, at the bottom of this chart, you're going to see that Amazon's listing regions, availability zones, and edge locations as physical infrastructure. Just know that Amazon has also added something called local zones, and they've added something called wavelength zones as well. Not really going to dive into wavelength zones. That's actually for cellular 5G usage. But local zones are basically availability zones that are no longer in the region. Let that sink in for a second. So local zones are availability zones that are no longer tied to the region. So I'm going to talk about that. There's no slide in here for it, but I'm just going to talk about it because it was released recently. It really is only used if you need really low latency applications co-located with your users. And there's only a limited set of local zones. So there's one in Boston, one in Miami, one in Houston, and there's one in Los Angeles. They're about to release a bunch of others, but they're basically an extension of a region. So it's just an availability zone that's actually not in the region that it's affiliated with. So we'll talk about that a little bit more when we get to regions and availability zones, which I think probably the next thing, actually. So here's some of the other services. You're not meant to memorize this, just noting the different categorizations, right? If you go actually back to the console and look at console home, probably a better way to see the different categorizations that AWS has for their services, such as compute, containers, which they actually segmented out from compute at some point in time, but really it's just a variation on compute. And then you've got your storage sections, your database section, migration and transfer, obviously base networking, including content delivery networks and whatnot. All your developer tools, things for help desk and customer enablement, and then of course all the little management and governance pieces, as well as analytics, machine learning, and others. So there's a ton out here, but this is where you would go look for the categorizations that you're seeing here. Some other products and services, including mobility services, IoT, of which that's just a fraction of the IoT services they actually have now. This slide was updated recently, but if we go out there and look at console home, you'll see that under IoT down here on the lower right-hand side, there's a bunch of options here. Okay. So let's talk about AWS's physical infrastructure. But before I move forward, were there any questions just about the general history, service availability, just the general fact that there's a ton of services out there for AWS? Does anyone have any questions this far? Yeah. Okay. So this may also be a refresher, but you've probably seen this before. So as you probably well know, regions is just a geographical area where AWS has basically clusters of data centers. And they're subdivided into what's called AZs, or availability zones, of which, there's usually at least 2 for every region. Now, I know you may remember that in Japan, they had Osaka, which only had 1 availability zone. That's changed, so now it's actually a real region. And that was just for Japanese government usage anyway. But now note that while this map is just slightly behind, it's pretty accurate as far as what they have available right now. 77 availability zones going in 24 geographic regions, of which I think they have 3 more emerging, if memory serves. And not only are they announcing regions where they're putting 2 or more availability zones that make up that region, they're also announcing what they call local zones, which are attached to regions. So they don't have a map for this yet, which I've kind of been onto them about this, is that regions are actually, local zones are really just availability zones that are actually put somewhere, like Boston or Miami or Houston or Los Angeles. And they're actually affiliated with a region because they're just availability zones that have been pushed out. So it's just a single data center, basically, that's been pushed outside of the region. And so, by the way, if Boston, for example, if that local zone fails, you have to fall back to Virginia because that's the affiliated region for fallback, right? So just know that there's actually now 5 locations. So there's regions, availability zones. There's local zones, which are really just availability zones that are outside the region. Then there's edge locations, which we'll talk about in just a second. And there's wavelength zones, which are really for 5G usage. So there's at least 2 availability zones per region. You probably know this. You probably know that Virginia has 6. You probably know that Oregon has 4. There's some out there that have 3, as an example. That they all come with these codes like US East 1, US East 2, US East West 1, US West 2. Sometimes they're shorthanded, right? But typically that letter denotes an availability zone inside that region. Just a question for you. Does anyone know off the top of their head, out of all the regions that are available, for example, in the continental United States, which one is actually the most expensive by typically 10 or 20%?
Seattle.
Sorry, say that again.
The Seattle one? The one in Washington State, I think.
Yeah, so oddly enough, the one in Oregon, US West 2, is actually not one of the most expensive ones. That's where a lot of new services are released. It's actually California, US West 1. US West 1 is consistently 20% more for the exact same workload than the other regions in the continental United States. Usually on every continent, there's one region that's a little bit pricier than the other regions. Like, for example, Tokyo is typically pricier than the other regions that are in the Asia Pacific, as an example. So, just something to be mindful of is that when you're choosing a region, you might want to do just a quick cost comparison, unless you just have a compelling reason that you must be there. Like, there are definitely, customers in the state of California where you're going to need to co-locate in California to make that work. Just a little side fact. Okay, so best practice with AWS is they are partitioning the availability zones independently with independent power and internet. So what that means is that while they are connected through high-speed private interconnects, these availability zones all have independent power, cooling, and internet connectivity. And so best practice is that you always run any production workload if it needs that level of high availability, and this is all driven by the business, obviously, that you want to make sure that it has 2 instances, one in one availability zone and one in the other availability zone. Otherwise, you're only going to get 4 nines of uptime against your EC2 instances. That might be good enough, right? But it might not be good enough depending on your application and how your load distribution is being handled. So the other thing to note is that across different AWS accounts, the availability zones don't actually physically match. So, if Jagar and I both had accounts and he had US East 1A, and I had US East 1A, so that's Virginia, that's the first availability zone. Our A's actually physically wouldn't necessarily match. So just so you know, his A might actually be C for me. So just be aware that the letters that they assign you in the console in your account, for all the availability zones, they're not consistent for every single account. That Amazon actually rotates them, because people are always choosing the first account or the last account or the middle account. And so you get this weird thing where B and D are actually not being used, for example, inside of, US East 1 as an example. And so they started rotating it around so they would actually get a more even distribution of server consumption and resource consumption. So another little fun fact. Now, edge locations are basically where Amazon has worked with major ISPs to put either a server or a rack of servers in, mainly for caching purposes. That you can push some compute with Lambda at edge, for example, where you can push serverless like authentication and authors like login functions out to the edge closer to the user. But these edge locations are mainly used either for caching, protection, filtering, mainly caching is what it is. And whether that's DNS redirection or the actual caching of video files, images or whatnot, that's mainly what these edge locations are for. They are usually scattered, you'll see them on a map and they're just like scattered all over the place. But there's a reason to the madness. They're actually associated with major ISPs. So as like you look at South America, if you find out where all the major ISP connection points are, you'll find that Amazon has a caching server there. Same with Asia Pacific, same with Europe, right? Same with the Americas. Okay, so 5 places, one of which we didn't really dive into. So let's say 4 regions. Availability zones make up regions. Local zones are just availability zones that are outside the region, but they're affiliated with the region. There's only 4 of them that I know of right now: Boston, Houston, Miami, and Los Angeles. And then we have edge locations, which is what we just talked about, which is basically where Amazon doesn't necessarily have data centers, but servers and server racks of servers where they're using caching for enabling the data distribution. Okay, so most of you have seen the console already. As you can see, because I have an @ sign in my name that actually refers to the account alias that I'm actually logged in as an IAM user. Obviously includes things like my account number, quotas, security credentials, if I want to switch roles, etc. And then of course, here's all of the region listings that I was looking at before. Probably all very familiar with this, so nothing new. And then of course, any support options I'm looking for. And if I have a business or enterprise account, some of these options will change. The rest of this, as far as the management console itself, you're probably also very familiar with. There's the console home. And then of course, if I go into like a specific service, let's say S3, for example, you'll see the context also, by the way, switch, because some services are regional. And so they're kind of managed globally versus if a service is availability zone specific and is managed regionally. Just to make sure that makes sense. Obviously, when you go to start a virtual machine, it has to live inside a network that lives inside of an availability zone, and that's inside of a region. So when you go to manage something like that, you actually go one step up. So even though S3 is a regional service, how do we know that? Because these buckets down here, these little folders for hosting storage, for hosting data, you can see that their home base is listed as a regional basis. But in order to manage that from a regional basis, we actually go up to a global level. And so just know that when you typically manage services, you'll go up one step in order to manage something that sits at a slightly lower level. So remember, it goes availability zone, region, and then global. Can anyone name another service that you know for a fact is global across your entire AWS account? What about this? Username and passwords, right? If we go look at IAM, you'll see that the context will stay global if I switch over to IAM, because your users that you create in your AWS account are global no matter which region you're in, right? So they're going to span the entire set. What about DNS, right? DNS is another one. If I go take a look at Route 53, Route 53 stays global as well. But if I go to an availability zone specific service like EC2, as an example, what will happen is that you'll see it switch back to a regional viewpoint because it actually wants me to start a virtual machine inside of an availability zone inside the region in particular. If I come back to another availability zone specific service such as RDS, which is the relational database service, notice that that is also very much an availability zone specific service as well. And so notice that it has a regional rubric on the upper right hand side. But if I switch to DynamoDB, it should actually also stay regional, because while DynamoDB doesn't necessarily put something in an availability zone, it does actually run at a regional level, even though it can go global. So just note that that context is actually really important. Typically on the left-hand side, you're going to have your options for, even if you don't necessarily know specifically what they are, you're going to have your options for different objects inside of the console. And in the main areas where you're going to do things, for example, like create a table and set things up and follow the particular wizard or steps that are being presented. EC2, for example, if I actually had running instances, which I'm trying to start some actually to get better demos, they would actually be listed right here. And as you clicked into those, the lower window would actually show some information as well. So just know that it usually goes from left to top to bottom if you want to see information. Let's go look at that under VPCs, because that might actually give a better viewpoint of what I'm talking about. So virtual private clouds are a networking function. So if I actually click in the VPCs and I click one down here, all of a sudden I'm going to get information down here, depending on which one of these objects I pick. So on the left-hand side, I'm on VPCs. On the top side, I'm picking a specific object, and down here I have information about the object in question. Do note that there are tabs inside that lower right informational pane as well. Now, for those of you who spend day-to-day in the console, you're probably super familiar with this. You're like, yeah, that all makes sense. That's what I've seen before. Any questions about any of that for anybody? Okay. So a little knowledge check. Throw this in there. What is the AWS term for a physically distinct group of data centers that are inside of a region? What is that called? You can type it in chat or say it verbally.
Zone.
An availability zone.
Yeah.
Glenn, I definitely wouldn't say zone, because that's going to get confusing.
Availability zone.
There's 3 other types, right? Good. Availability zone. Excellent. Good. All right. So then what is the name of that weird construct I was talking about before, where it's like an availability zone, but it's actually outside of the region?
Local zone.
Location.
Good. Yeah. Local zone. If we go take a quick look at AWS local zones, basically what they're doing is they're actually moving to Boston, Houston, Los Angeles, Miami. They're moving these availability zones outside of the region into closer to a city, basically a metropolitan area. And so they don't have a good map on that, which I've been asking them for. But if you want more information about local zones, you can actually engage with their interest form. If you're just looking for the base page, right, you can actually just start here. This seemingly looks like it's still in beta. They actually just released it for general availability recently. So I'm not sure why there's still limitations here about getting information. Good. Question number 2. Does AWS have, is this true or false? AWS has more regions than edge locations. Do they have more regions than edge locations? So I think that we saw that there were 24 regions. If we were going to take a look at edge locations, Let's go take a look. AWS edge locations. Let's blow that up for a second. Also known as points of presence. Now those blue and purple dots are the edge locations. Does that look like more than 24?
Yes.
Yeah, it does. Right? So this is actually, AWS does not have more regions than they have edge locations, right? So the answer is actually false. So they don't have more. They have by far more edge locations than they do anything else, because the edge locations are ISP associated, right? Whereas the regions are actually independent centers, clusters of data centers that AWS has created. Good. So in terms of using cloud computing, is this true or false? Does AWS own and maintain the infrastructure required for application services, and then customers basically provision and use them as needed? That's probably a pretty basic question, right? We're not actually doing anything around infrastructure, at least not at a base level, right? We might be doing things with the operating system and above and asking for provisioning. But for the most part, we just use the services. So that's true. All right. What is the relationship among availability zones in a particular region? I wonder why that's blank, actually. What are the characteristics? Like, what makes an availability zone significant? What is its relationship to a region? For example, are availability zones isolated from each other or tightly connected with each other?
Isolated.
Isolated, right? Is there anything that is independent with each availability zone inside of a region?
Its name.
Definitely its name, right? What else is independent? What else is unique?
Oh, independent. Oh, it's power supply. It's internet source.
Yep, absolutely.
Equipment, yeah.
Yeah, independent cooling, independent power, independent networking as well to the internet in particular. Now they are, by the way, connected through low latency links, so there is some connectivity there, and they're very high speed. So typically, you're only going to see somewhere between 1 to 5 milliseconds, maybe, of latency between availability zones in a region. You obviously can see more depending on what is going on in that particular region. Good. Are there any questions about AWS's physical infrastructure that you wanted answered or to ask right now? Okay. All right, well then we'll move on to the next thing. Notice that questions are welcome at any time, even if I'm talking. I usually, though, will take a breath to make sure that people get a chance to talk. So feel free to intrude. Say, Michael, I have a burning question. So let's talk about the foundational services, and then we'll move upwards from there. So we're going to talk a little bit about EC2, a little bit about VPCs, and then just some storage concepts. Just to ask this, do you also have to provision VPCs, the Wintel team, or is somebody else, the networking team, responsible for that?
I don't think Wintel does that.
So they usually tell you where they want you to deploy, or they label them in some form or fashion?
Yeah, those are created by our engineers, and we deploy then to those availability zones.
Yeah.
Okay.
Or to the VPC, should I say?
Okay. That's not uncommon with companies, especially if they're organized around technologies. They'll function. There'll be different teams that do those pieces. That's very common in enterprise setup. Okay. We are going to do a lab. Ooh. Actually, let me check on something really quick. Did this actually start out? No, it didn't. Interesting. Okay. My own personal question there. I'll figure it out later. Okay, so EC2 you're very familiar with, right? So it sounds like most of you at least have started and provisioned EC2 instances. But this is basically, it's the virtual machines that we've known and loved since what, 1999, when VMware first published their desktop. Oh God, what was it called? The first desktop version. And then in 2003, when they came out with vSphere or ESX, that was the first kind of commercial data center product, I think, that would allow us to run virtual machines on a variety of Intel boxes. So this is very similar in that you can run virtual machines of a variety of t-shirt sizes, flavors, and design types. So when Amazon went through and designed virtual machines, they designed them with certain components added in and also certain ratios of memory to CPU. So for example, some of the machines have really fast ephemeral disk on them that can handle 385,000 IOPS a second for random IO at a 256K chunk size. Some of them, right, have 24 terabytes of RAM and actually give you access to the hypervisor and give you 448 cores as a result. So Amazon has a swath of some crazy variety of instance types, but basically this allows you to get you access to virtual machines in the specified configurations. Does anyone know off the top of their head the 3 operating systems that AWS supports? Obviously, Windows is one of them.
Unix.
They don't support Unix, they support Linux.
Linux, yeah.
Yeah, but they don't support Unix. I know because I used to be a Solaris engineer and I tried to get Solaris running on Windows and they were like, we don't really support that.
It's
No.
Linux and Ubuntu, or Red Hat and Ubuntu.
Right, they support unlicensed and licensed versions of Linux. So we got Windows, we've got Linux. What's the third operating system they support? Which I don't think anybody here would consider it to be an enterprise operating system, but they do support it and they just did so in the last year. Let's go take a look, actually.
Mac.
Yes, and I'm glad that you chuckled around that because I feel the same way, actually. They actually support Mac as of within the last year. And, I understand the need for testing, if they need client testing or whatnot. I'm just surprised they made it a server. But whatever. I'm not in charge of and I don't see their business plans. But if you go in and you go to launch an instance, the first question it asks you, it says, what AMI do you want to use? Now, in most cases, obviously, we're going to use our own AMIs because we're not going to source straight off the vendor, right? We're going to write our own. But notice that Amazon Linux is here, which is it's kind of a RHEL clone, so a Red Hat Enterprise Linux clone, if you will. But then there's Mac OS available, those are the 11.4, 10.15, and 10.14. And then you've got your standard RHEL instances, SUSE, Ubuntu, and then of course Windows 19 with all of its various pieces. They also have Linux with SQL pre-installed. So there's a bunch of options here. I forget how far this goes back. I know I've seen 2016 in here. I'm sure in 2012 R2, but anyway, yeah. And they've got deep learning machines, for AMIs for machine learning and artificial intelligence. But they officially support Linux, Windows, and Mac OS. So basically, when you request these virtual machines, you answer a couple of questions, you spin them up. And, obviously you can create launch templates and launch configurations as you see fit. If it's an unlicensed operating system, you pay per second billing. I just saw an announcement actually 2 days ago where it looks like now for Windows, it's down to per second billing as well. It used to be per hour billing, which is, by the way, how it all started. With Mac OS, by the way, just to be forewarned, if you start one, I think you have to pay for a minimum of 6 hours. And I'm sure they have some weird licensing agreement with Mac. If you ever just decide to go out there and kick one up, make sure you read the fine print about how much you're going to pay for it. Again, it's only going to be a buck or two maybe, but just be aware. Notice it says choose Linux or Windows. They haven't even updated it for Mac OS yet. And you only pay for the capacity that you ask for. That's a little misleading where it says pay for the capacity that you only actually use. That's not accurate. Yeah, actually, you pay for the capacity you ask for. And you all know this. If you ask for a 2-processor 4 gig machine and you use 5% of it, you're paying for 100% of a 2x4 machine. You're not paying for 5% of it. So that's a little misleading because actually you pay for the capacity that you've asked for. So they assume that you're using that capacity. So don't be fooled. Now, EC2 instances sit inside availability zones that sit inside regions. So it would be like US East 1A, US East 1B. You would be inside of a letter designation, an availability zone, inside of a subnetwork that's inside that availability zone. Because subnets don't span availability zones, which you'll see when we get to networking. You actually have to have it like in a single availability zone. One thing worth mentioning is that if you're ever trying to size a virtual machine and you're kind of like, the vendor says, I need this size of system, there's this great website, and it's, I know it as ec2instances.info, but a company called Vantage just bought it recently. What this is this actually has an EC2 and an RDS tab, and you can actually come in here and say, you know what, I need 64 gigs of RAM. What do you got? And it will show you all of the 64 gig systems that are available inside. And this scrapes, by the way, Amazon's API for listings of what's available. Notice that it will include older generation stuff. So, typically when you use EC2, you want to try to use the latest number, and you want to be very specific about the family prefix. In other words, there's a C here, and that basically means compute. Right? Now, there's also letters after the number, which means that's a Gravitron processor with an NVMe RAM disk attached to it. How do you know this? Well, you actually have to go read the documentation, as I'm sure you're well aware. Now, the great thing about working for most enterprises is that typically you get a pre-approved list of machine types that you can actually use, of family types you can use. But like that C type right there, that C stands for compute, which means it has a ratio of 2:1 between memory and processor. If it was an M type, it would have a 4:1. As you can see down here with the M5A, that's a 4:1 ratio between memory and processor. If it's an R, it has an 8:1 because that stands for RAM or high memory type. That's an 8:1 ratio between memory and processor. What do all these letters mean after it? Honestly, they change so fast, you're gonna have to look them up, but most of them I do know, right? So like if it's a G, it's a Gravitron processor, which means it's ARM based, which is not gonna work for your x64, x86, 64 instruction sets, right? So something to be mindful of is be careful if it has letters after the number, because it's probably not a base Intel system. It could be, but you wanna check and make sure. But if it's like a C5, for example, just to show you, if it's a clean like C5, notice that this is an Intel-based box. It has no G's, it has no D's, it has no A's, it has no N's after the number. That also means, by the way, it's the 5th generation of box because it has a 5 next to it. So the C stands for compute. What did I say was the ratio of memory to CPU for a compute designed instance? Does anyone remember?
2:1.
2:1. What did I say it was for the M or median series, the general purpose series?
4:1.
4:1. Good. Then you can get the last one pretty easy, right? What's the R series? Right? 8:1, because we just did 2, we did 4. Now we got 8. Good. Now, don't get me wrong, there are other types out here. How would you find them? Well, it's really easy. You go to Google, you type in EC2 instance types, and instantly one of the top links typically is going to be documentation on the EC2 instance types. And if you're like, you know what, Michael, I'm really looking for something that has GPUs associated with it, click over here to accelerated computing, and instantly you will see a list of the types that have GPUs associated with it. And then once you find what you're looking for, let's say you're okay with 8 NVIDIA A100 tensor cores, you can come up here back to ec2instances.info, and instead of typing C5, you type in P4, and there's the P4D, right? Of which apparently there's only one type. There was also a P3 there. You can see those various types. So notice that you can use this website in conjunction with the official AWS documentation to find the exact processor, memory, and or other special attributes EC2 system that you're looking for. So if you haven't seen this site before, I would definitely bookmark it. But this, in conjunction with the AWS documentation, will allow you to target specifically the size of system that you want to find. Questions about that? Hopefully that's useful. Hopefully you're like, I know about that, Michael. Storage optimized, by the way, is also IOPS optimized, which is what the I series is. Data warehouse optimized, which is what the D series is, and just general optimization or long like data warehousing is the H1 series, right? Note that some of these systems are using mechanical hard drives. If it has a mechanical hard drive, it's built for data warehousing. It's not built for speed. It's built for warehousing. Okay, so just something also to be aware of. Let's see, general purpose compute, memory, accelerated storage. Oh, one other word of, and you may already be aware of this if you're already dealing with this, is that if you're using the T series of instances, like T2s or T3s, be aware that there are T3As and As now. So like there are other processor types available. You may be aware that these are burstable instances. So be mindful about how much you use these in production, because they will only go to their maximum processor speed for that as long as they have CPU credits. Otherwise, they have to remain idle in order to gain CPU credits. Amazon will tell you that the T series is great for general purpose. I will tell you that they're great for tests or really variable workloads where it's quiet 1 minute, burst the next, right? So burstable workloads are great for the T series. So keep that in mind. C is for compute. M is for median, so that's just general purpose. R is for high RAM instances. T is for general purpose burstable workloads or test. And then you've got a bevy of other numbers like the P series, the G series that are good for accelerated GPU. And you've got the Ds, the Is, and the Hs for data. By the way, that doesn't mean that you can't take an R series system, grab a 64 or 128 gig box or 256 or 60 gig box, and put really fast disks on it and make it a awesome database box. Just to be clear, most people still use the C's, the M's, and the R's for practically everything, unless it's machine learning or a really specific workload. So just some guidance there. I was joking earlier about the metal boxes. Just note that if you want to see that 24 terabyte box, there it is. The U24TB1.metal, which is basically access to a bare metal box. Notice that there's no pricing listed for that, right? But that's a 24 terabyte hypervisor basically with 448 gigs of RAM. All right. Questions about instances, EC2 instances? All right, so we talked a little bit about like characteristics in terms of like, does it have the 64 gigs of RAM versus 32 cores versus 16 cores or whatnot. We already talked about the flavors of operating systems, right? We talked in general about the general family types, general purpose, compute, memory, accelerated, and storage, right? Which all have different letter appellations that match them. Amazon puts this slide in here every time to let you know that they do have Xeon processors, right? They also have AMD processors. They also have ARM processors, and they also have their own custom designed ARM processors called Gravitron. So it's becoming a very, I just want to say this, a little bit of a confusing move, but obviously there's business need for that out there on their part. But there's lots of options and opportunities for other architectures. Note that if you need access to P and C states inside of a processor, you can actually do that by choosing like the E5 or E7 processor family with Intel. Just know that I have never even heard of anybody asking for this, but I know someone did, because otherwise Amazon wouldn't have done it. Just a reminder that if there is a C6 and it is not changing our processor architecture, then you want to use a C6. So here is the compute instance, and they're just talking about Xeon in general. If there's a T3 versus a T2, try to use the T3. You might say, well, Michael, why? Like, what does it matter if the T2 meets my needs? Because the T3 will be cheaper and faster. So the latest generation of boxes in any family, if it's like an M4 versus an M5 or an M6 versus an M5, the latest number will always be cheaper and faster than its predecessor. Amazon, as they get better at running infrastructure, their latest generation systems will continually grow better, faster, stronger at a lower price point. And since Amazon and in general the industry encourages somewhat ephemeral infrastructure, meaning you're not running boxes and letting them sit out there for a year, they're out there in production behind a load balancer, and they're probably recycling, once every 30 days, maybe once a week, meaning you're getting new boxes spun up, maybe with new patches or just refreshing state. You're not running persistent workloads out there for years at a time, unless it's like a database or something else that has strong state to it. You're constantly automating so that you can actually redeploy these systems and getting fresh boxes as you need them. That can, in many cases, just include changing the underlying hardware by getting the latest generation of instances. Here's just an example of how the t-shirt sizes work, because you may notice that we talked about the C5, for example, versus like the C6, and that's the compute family, and the 6 is the latest generation. But we didn't necessarily talk about the t-shirt sizes because there is, in a sense, small, medium, large, extra large, 2x large, in this case 4x large, 9x large, and they're really just multiples of extra large. So that way you can easily figure out in your head how to scale a system if you know what the base instance is. So in this case, the C5N, it's got 4 CPUs and 10.5 gigs of memory. So then the 2x large is just double that. The 4x large is just 4 times. Do note that network bandwidth scales with size. So the bigger the box, the bigger the network pipe associated with the box. One little caveat, adding network cards, they call them ENIs in Amazon, does not speed up a box. The box has a fixed amount of bandwidth and it will not go beyond it no matter how many network cards you add to it, because the bandwidth is tied to the box, not to the network cards. So if you ever see like, oh, hey, look, there's an elastic network interface, I can add more network cards to my system. It won't actually speed up your boxes. It actually just acts as a management partition. That just reinforces what I said earlier about making sure that you're using the latest generation, because it's going to make things really fast, right? So just making sure that you are trying to use the latest generation if possible. So when you launch an Amazon EC2 instance, which I'm sure you've done before, you've gone through these steps where you basically identified the operating system you want to run. You then picked the size of box that you wanted, right? And then you just configured the other things like subnets. What are the firewall groups doing? How am I going to log into this via key pair, right? What is the key pair I'm going to use in this particular case? And so just know it's the same standard process of where am I going to run it? What operating system am I going to boot off of, right? What are the size? What's the size or the characteristics of the virtual machine, like hardware that's going to run here? And then where's it going to run and what are the security parameters? It's the same questions every time for EC2. Now the AMI is pretty important because Amazon in the industry in general is pretty keen on what is your response time when you need systems to boot. So it's typically recommended that you stick as much configuration and software into the boot process, into the image as much as possible. And that the only thing you're doing when you're booting is just doing some configuration. And most companies have an automated image creation process that has different images for different scenarios. So there'll be an image for SQL Server, and there'll be an image for IIS, and there'll be an image for some other like piece of software. And what will happen is when it boots, you're just adding in the application specific items, or hooking into Active Directory, whatnot. You're saving those last minute configuration items because you want that system to boot as quickly as possible. If it's spending most of its boot time in configuration, then that's not able to respond to failure as quickly as possible. Not only that, configuring on the fly can sometimes fail, and that's an opportunity during transition to fail, especially during crisis. So people are focusing more and more now in the industry on immutable infrastructure, where configuration, for example, is done with, like, let's say Ansible in this case, in the boot image. The boot image is configured, and now you've got boot images for specific scenarios, and the boot time is reduced. So instead of waiting, anywhere from 5 to 10 minutes or more to boot an instance, you'll get what you see now, which I saw the other day, a Linux box boot in 15 seconds from click to go. And I was like, man, that's a great boot time. And it had a decent amount of configuration in it actually as well. Notice that the AMI, or the Amazon Machine Image, which is this bootable operating system we're talking about, also contains things like, what disks do I have associated with it as well. So it does contain some configuration information about the hardware that's attached to the image. So you're probably aware that AMIs are region specific. So if you want to copy an Amazon Machine Image, you want to copy that boot over to something else, you can actually just use the API. Or I don't know if actually there's an option in the console to copy to another region. Maybe there is, but you can actually copy it programmatically through the command line as well. So if you want to take your awesome image that you have in US East 1, you just copy it over to US East 2 and then deploy it as you see fit. Note that when it goes over to another region, it does actually get another AMI ID, because AMI IDs are specific to the region the AMI lives in. So and every single instance must boot off of an AMI. When you're running EC2 instances, as mentioned before, they go into availability zones, and they usually have attached what they call EBS volumes. EBS volumes, for all intents and purposes, can be considered kind of direct attached storage. It actually does run over the network using iSCSI, but it looks direct attached and certainly performs direct attached. I saw that they're coming out with a new version that does 128,000 IOPS per second at 256K chunk sizes. I was like, it's impressive. So when you deploy a virtual machine, you're going to stick it inside of an availability zone. Now, the life cycle of an instance, tends to be, okay, we're starting, which is pending, right? Now we're running. And then when you stop, or stop hibernate, which, by the way, stop hibernate is only for a very specific set of circumstances. Stop, it allows you to obviously go into a stopping state, and then you stop it. Now, when you stop an EC2 instance, you're only paying for the storage, you're not paying for compute. So that only works, by the way, if you use what's called EBS backed instances. That means that you've taken the EBS service, which is the hard drive service, and you've attached a hard drive to your EC2 virtual machine. If you decided not to use EBS and you're using instance back instances, you can't stop instance back instances. Matter of fact, it's highly recommended that you don't use instant storage in AWS if at all possible, because it is ephemeral, and if the box crashes, your disk is going to disappear and you can't get it back. So make sure that you're using EBS backed instances if you're using your virtual machines. Save instant storage, which is sometimes free as part of running a virtual machine. Save that instant storage for things like caching or scratch directories, or things that are easily recreatable. So just know that with your bootable virtual machines, try not to use instant storage for anything important. Once the system is started, it goes back into a pending state, and then it's running. And then, of course, a reboot is just a reboot, and it'll tell you that. And then, of course, if it's being terminated, it will shut down, and then it will say terminated. It's done. It won't say ended. It says terminated. Any questions about the life cycle thus far? Probably knew that already, but you never know. Hibernation, by the way, is a relatively new thing they introduced in the last few years. There are some really interesting limitations about being able to hibernate a system. I don't know that I've had a customer yet who's asked for that use case, but someone did. Otherwise, AWS wouldn't have done it. And so, but it does allow you to take everything in memory and dump it to disk, and then restore it, obviously, with that, the contents when it boots back up. You may be aware of instance metadata, which is a little bit like user data, in the sense of that well, actually, so is it like user data? I mean, we'll come back to that. Instance metadata is basically just data about your instance, and you can actually get access to it pretty easily off the command line just by either curling or getting this 169.254 loopback address. That's an RFC private reserve of some type, I think for host lookup actually. And so 169.254.169.254/latest/metadata allows you to find things like the AMID that was used, the IP address. This is very useful for internal scripting when you're trying to grab information about the instance and you want to get it from within the instance. You can actually just do a local loopback. There's no permissions here because it assumes that if you're logged in, you have permissions to access this unchangeable static data. If you replace metadata dash data with user dash data, it will tell you all the commands that the instance was told to run at boot time, at first boot, right? And so all of this is returned as text, but if you ever need to loop back and loop around in order to find metadata information, this is a great way to do it. User data is the same thing in the sense of like, this is data that's actually passed to the system at launch. There are versions of this obviously for Linux and for Windows. Amazon designed an EC2 launch service for this purpose, right? And what it will do is it'll run the user data scripts at like first boot, at first launch. And so in this particular case, there's a Linux example where it's just actually installing Apache web server and starting it. And this is actually passed in when you create the instance, which then allows the instance actually to run those commands on boot time before it like finishes its final stages. Windows is the same thing, right? Here it's importing the server manager module, right? Looks like it's enabling IIS and some management tools. And so that's user data. And that allows you to change the configuration of the system upon first boot. It will not help you with a running system if you reboot it, for example. This is only for first boot changes. If you want to retrieve that user data, it's the same local loopback, right? You just do a curl or an HTTP get of some type. And you can curl, like in this example, you can see them curling against latest user dash data, and they're pulling back everything that was used to start that Linux box. In this case, it looks like it updated, and then it looks like it added PHP and MySQL along with the Apache web server and did a bunch of other things, like started it, added some groups, etc. So user data and metadata are both accessible through that URL, that 169.254 URL. Note that that does show up, for example, on certification exams quite a bit. That 169.254, 169.254/latest/metadata or /latest/user dash data. So something you want to be mindful of, not just for your own usage in your own scripts and PowerShell scripts, but also if you decide to take the exams as well. Any questions thus far before we talk about EC2 purchasing options? All right. Sorry, just checking on something really quick. Okay. Okay. So there are some pricing options here. You might be dealing with them, you might not. So first is on-demand pricing options. So when you start an EC2 virtual machine, you're actually, if you don't have any kind of like savings plan or enterprise agreement or any kind of what they call reservations with AWS, then you're starting it on demand. And what that means is that you're paying probably you're paying like retail price basically by the hour or by the second, depending on what operating system it is. But most of them are now approaching by the second billing. And so what happens here is that if you're done with the system and you want to give it up, you just give it up. There's no negotiation. You just give the resources back, and Amazon takes it back, and you stop paying the minute you stop the resource. If you decide that you're going to run a workload for a year or 3 years, so remember that 1 year or 3 years, and you're like, you know what, I really would like to actually save some money here. Amazon, will you give me a discount if I commit to pay for this resource for a year? And Amazon say, yeah, great. I'll give you a 20, 30% discount if you go for a year. I'll give you even deeper discounts if you go for 3 years. And by the way, this all happens through the website, so you don't need to go and change anything. You just go and make a reservation and you pay for the reservation or commit to the reservation. And what that means, by the way, is that the first of every month, you will be billed in full for what you committed to, regardless of whether you're using it or not. But it's going to be at somewhere between, a 20 to 70% discount if you do a reservation. So reserved instances give you a significant discount depending on how much money you put down up front and how long you say you're willing to keep this workload running 24/7 for. By the way, usually within the first 7 months, you will break even from if you would run it on-demand pricing. And in 3 years, I think it takes, I want to say it's at like month 20 or month 19 that you break even versus on-demand pricing. So at that point, after month 7, if you commit to a year, those are just basically free months at that point in time, even though you're still paying, right? But if that was on-demand world, you are now over and above on-demand pricing in month 7. So remember, reserved instances, also known as reservations, are available in 1 or 3 year terms. You can also put a balloon payment down up front, either none, some, or a bunch of balloon payment down up front, and your discounts will get steeper as you put more money down up front. Because as you can imagine, Amazon considers money in hand now worth more than money in hand later. So you get deeper discounts as a result. There's also scheduled instances. So something to be aware of is that with scheduled instances, what's happening is that you're purchasing reserved instances, but instead of running them 24/7, you're saying, look, we only have peak traffic from 8 a.m. to 8 p.m. Monday through Friday. So can I just get a 20% discount if I just commit to paying for, 12 hours a day, 5 days a week, which would be, 60 hours a week times whatever days in the week. Can I just commit to paying 240 hours a month for this instance? And Amazon won't give you as deep a discount, but they will give you a discount just for your commitment to pay for that workload for a year. And scheduled instances, by the way, can only be run for a year. So if you want to run it 24/7, you have an option for a 1 or 3 year term. If you want to slice it up and say, look, just the first day of the month, I need an instance for 24 hours, or hey, I want to run it Monday through Friday from 8 to 8. That's going to be a scheduled instance. You can only do that for a year, and you have to renew it every year thereafter. Those are both types of reservations. So you are committing to pay Amazon for either a year or 3 years for that workload, regardless of whether you're using it or not. Any questions on those two EC2 licensing types thus far? Okay. And there's spot instances, which I used to joke was the eBay of EC2 licensing types. It's really no longer the eBay. Basically what happens is that Amazon says, look, we've got a bunch of extra unused capacity. So normally you'd pay $1 for this instance. We're selling it for 90 cents. Do you want it? By the way, what happens is if you say yes, it will give you the virtual machine, but only until a customer in the on-demand or reservation section comes in and asks for that type of machine, which means the value of that machine will go up because somebody who actually is going to pay full retail price wants it. You'll get a 2-minute warning, and then it will shut your machine down, right? So this spot instances are only available for workloads that can be interrupted and that don't have a time constraint. For example, let's say you're running a report at the first of every month, and it takes 4 or 5 days of compute processing to get that first of the month report done, what can happen is that you can just use spot instances to run it until you get to like the 25th or 24th of the month. And then you realize you only have 4 or 5 days left, but you've done 3 days worth of processing. Then you can use 2 days for on-demand instances. And you might say to yourself, Michael, that sounds horrible. Why would I want to risk having my workloads interrupted? Well, if it can automatically suffer resiliency and it can just pick up at any point in time, it might be worth it, because just so you know, spot instances are often 90% discounted off the retail price. So imagine instead of paying $1 for, let's say instead of paying $100 for your report, it costs you $10. All because you just orchestrated it out to be a little bit resilient and checkpointing when it came to being interrupted, right? So just something to think about is that there can be significant cost savings if you have the architecture to support it for an application that like processes data, writes it to an external database, processes data, writes it out, and just does that, let's say every minute or so. And so if you have that kind of situation, then spot instances make a tremendous amount of sense. This is great for genomic computation, batch processing, oil and gas, GIS. Reporting obviously is a great one as well, where you're just doing continual number crunching, but there isn't necessarily a date associated with it. You just want to get it done. Because guess what? At 2 o'clock in the morning, at least in the United States, there's probably not a lot going on from a processing standpoint. So those instances could get pretty cheap. So overnight, you could be running your batch jobs using spot instances. Now, there's also, by the way, high security and licensing instances if you need to not be in shared tenancy. What does that mean? It means that there are dedicated instances and dedicated hosts where you can just get your own physical box inside of Amazon. And you're like, Michael, what's the difference between dedicated instances and dedicated hosts? Well, with a dedicated host, you get basically a hypervisor host that you can run any number of instances on, and they're just yours. Nobody else can run on that host other than you. If you want a dedicated instance, I know this sounds weird, but if you ask for a 4x16 system, Amazon actually sticks you on a 4x16 box that nobody else is on. It's just you. So they're actually in both cases like dedicated hosts, but one allows you to run multiple virtual machines on top of it, and the other one is that you're just saying, I just want to isolate this instance so that no other piece of hardware, no other account is touching the same hardware that this instance is on. So in both cases, it's usually used for high security and high licensing requirements. Like for example, if you have a license key that's hardware tied, even inside of a virtual machine, you can actually get a dedicated instance or dedicated host, and it will compute that hash for that license the same way every single time. And there are what they call savings plans. Now, I want to be clear. On demand, all the way over to dedicated instances, those are licensing types. A savings plan is where you're basically buying a bucket of compute, and it's a discounted rate, right? And then what happens is that when you use either containers or serverless or virtual machines, in this case EC2, you're going to eat out of that bucket. So you might have $10,000 worth of what they call CPU or ACU credits. And every time you start a virtual machine, it costs you 10 credits. And so, 10 by 10,000, right? You can figure out how many hours of $10,000 it's going to get you. But that's what a savings plan is. A savings plan is where you put money down and say, look, I want to buy $10,000 of credits at a discount. And Amazon will give you up to 72%, I think it is. Actually, it says it right there. 72% discount off for your dollar. Right? So it'll go, 4 times longer because you bought some compute credits, basically. That is also available in 1 or 3 year terms as well. Okay, that was a lot. That was a lot, was it not? Like licensing types. Because we just talked about on demand, we just talked about reserved instances or reservations, of which scheduled instances are a sub of that. We just talked about what I used to refer to as the eBay or spot instances. which is the one that gets interrupted after 2 minutes. You get a 2-minute warning, but you could go for hours or days before someone actually asks for that particular type, but you get a 2-minute warning. And then there's dedicated instances and dedicated hosts, which are high security licensing types. And then there's savings plans where you're basically just putting money into Amazon in exchange for compute credits at a discounted rate. Does anyone have any questions about any of that? Okay. Let's talk about the rest then. So if you haven't been on the marketplace is third-party locations where basically you can get access to your favorite like software like Checkpoint or TIBCO or any enterprise class software is typically out there. You're looking for like a specialized database or, you know, the marketplace is actually pretty cool. I don't use it a lot because I tend to install my own software, but it is kind of an interesting thought that the marketplace is here. I know a lot of people who love to grab their software from the marketplace. So for example, oh, this has changed. Give me just 1 second. Here we go. Let's say you're out here and you're like, you know, I really love, you know, Kafka, for example, which is by Confluent, I think it is, right? You can get a couple of different variants or flavors, both from the vendor and from other vendors who are selling it as well. Or let's say that, you know, you're a big fan. What was the other one someone asked me the other day? Cognos? Was that one? Yeah. And so there's actually third-party vendors who are actually offering virtual machines and subscriptions to Cognos, both from a licensing standpoint and a virtual machine standpoint. So this is a great place for you to find third-party software that you're looking for. You know, obviously be cautious here. You want to have it be by somebody that you trust, like a vendor that you have a relationship with. And, you know, make sure you recognize who that is. They have an official website. You might even want to talk to the sales people just to make sure, right? Especially if it's someone a little bit more obscure. So that's the marketplace. And that's it. That's it for EC2 before we roll over to VPCs. So we're going to talk a little bit about virtual private cloud, but I just wanted to check in and see if anyone has any questions about anything we've covered thus far before we take a short break. Okay. So here's what we're going to do is we're actually going to take a short break. So we're going to take about 15 minutes. We're going to come back at 11. So in 15 minutes, whatever time zone you're in, because I'm not sure where everybody's at. We're going to come back in 15 minutes, and then when we pick it up, we'll do VPCs, and then we're actually going to do a lab. So we're going to like, get some hands-on experience. Okay. Not hearing anything, so let's go. We'll go take a quick break.
Okay, thanks.
We'll be back at
All right.
11.
Thanks.
All right. All right. Welcome back, everybody. Okay. Let's see. I see sound coming through, so hopefully everybody can hear me. Any questions that came up or anything that curiosities came up during the break?
I was just curious about the rest of our breaks. How's our lunch break? How's this day broken up?
Oh, yeah, Paul. Sorry. Earlier, so we're talking about like usually around noon, we're gonna stop for about 55 minutes. We're actually gonna just shorten it a little bit just because I want to make sure that I don't run over 5 o'clock, and so we'll determine that in the next hour or so, and then we're gonna take another break at around 3. So usually every 90 minutes to 2 hours, we'll take a break. And that's it. That's the rest of the day. So we'll take a slightly less than an hour lunch, and then we'll take another break at 3 o'clock. And then we're probably going to go pretty close to 4:45, 5. I will definitely not go over, but we'll be pretty close because unfortunately, just the nature of this single day, it's pretty jam-packed. Good.
Thank you.
Yep. Okay, so let's talk about the rest. Let's talk about VPCs. We'll just talk about virtual private networking, and then we're going to continue onward with a discussion or actually a lab. So virtual private clouds or VPCs are basically isolated network segments inside your account. You create up to 5 of them by default, although you can request more from Amazon, like the capability to create more. They call that a quota limit, by the way. And so you create it with some RFC 1918 CIDR information. So it's either a 10 network or a 172 16 to 31, or it's a 192.168 network segment. And then you basically create a VPC, and inside the VPC, you've already defined your overarching network range. You will create subnets that are slices of that network range. And so you do this so you can partition things out, because you can isolate VPCs and networks with their own firewalls and their own connectivity and their own route tables. So you define that overarching pie of networking, and then you put subnets that are a slice of that pie. Now, to be clear, VPCs span the entire region, but your subnetworks, your subnets that are slices of that pie, they have to fit within a single availability zone. So if you define a 192.168 network as your core network, and let's say that you then use like 192.168.1, 192.168.2, those will all be subnetworks, and we'll see some visuals here in a second. Those have to fit into availability zones. Now, there's this concept of private and public subnets, and it doesn't work exactly off of NAT, although NAT can be implemented inside of a network. What that means is that if it's a public subnet, meaning it's a subnetwork that you've created in your VPC, it has a route to the internet gateway for the VPC, which means it's literally routable to and from the internet. If it's a private subnet inside of your VPC, it is not routable to and from the internet because it doesn't have a route entry to the internet gateway, which allows it to talk to the internet. So in this particular case, to give you a little bit of a visual, you can see that on the lower left-hand side, there's some web servers on a public subnet, there's some app servers on a private subnet, and there's a VPN-only database subnet. Now, the web servers in the public subnet actually have a route to get to the internet gateway. You can see that little orange squiggly line going through the internet gateway. The application servers do not have direct access to the internet. They have to use a proxy, in this case, a NAT gateway, which works just like our cable modems and our DSL modems, fiber modems in our home, is they translate our private network into a publicly accessible IP address, and it acts on our behalf. So this NAT gateway that's listed here, right here in this little area where I'm drawing circles, this NAT gateway enables access. It acts as a proxy basically out to the internet gateway, out to the internet. Note that inbound traffic cannot really by default get into the NAT gateway. This is only for outbound traffic. like outbound initiating traffic. So, and then notice the database servers over here on this right-hand side, they're going through a virtual private gateway, which connects them through VPN back to a customer network. So now you could also put a NAT gateway over here for the database servers as well if they had to. For example, you could put a route that allows them to talk to this NAT gateway, and then they could actually get out to the internet from there. But in this particular case, that's not happening. Now, one thing to note is that when you get into a VPC, so here's the VPC. When you get into a VPC, you're coming in through either the internet gateway or through a VPN connection. You're hitting the route tables, which are listed here, right? And then you have to pass the first firewall called a network access control list, which is a firewall for the actual subnet. So the entire subnet, oops, I did not mean to put an error there. Hold on one second. The entire subnet is protected by this network access control list. This entire subnet over here is protected by this network. These are stateless firewalls. Once they get past the firewall at the subnet boundary, then they have to get past the firewall for each individual instance. These are called security groups. These security groups are firewalls that wrap themselves around the network interface, and they are stateful. Most of the time, NACLs are not really used unless you're denying IP addresses, or if you just want to have some stricter controls between networks. But usually security groups are defending by default. They allow all outbound traffic, but they will not allow the internet to get into any instance you launch. So even if you put a machine out on the internet, if the security group doesn't have a hole in it, the internet cannot get to the system. Note also that you will use key pairs to log into a system. You will not be using passwords, right? You have to have the private portion of a public-private key pair in order to log into a box that hosts the public portion of the key pair. So public-private key pairs have been considered to be the de facto way in which, admins want to log into boxes if possible, since like the early, to the 2013, 2014. And so that's pretty much the way Amazon has also adopted it since that time. Now, there's a couple of different ways to get access to AWS from a secure standpoint. Like if you want to put a tunnel across the internet, you can run your own VPN, and you can run it, device to device or software or whatnot. You can also, by the way, use Direct Connect. So you can not only use like your own personal software on your laptop to connect to a gateway, you can also use hardware connectivity between two VPN connections, and you can run your own physical wire. Using one of Amazon's network partners, you can run a wire to the partner and they'll run the rest of the wire over to Amazon. And you can actually get either 1 gigabit, 10 gigabit, or 100 gigabit connectivity straight between your corporate location and Amazon's data center. And it hooks right into your VPC at those speeds. It is private, meaning there's no internet weather to affect the connection, unlike VPN. And there are cheaper data out charges on a direct connect connection versus running across the internet. So if you are paying for data out charges, it's cheaper if you're using your own cable with AWS. And so now we're on to kind of our lab here. And I just want to check on something really quick before we kick into this lab. Let me just make sure they're active. Not active. Should be active soon. Good. So what we're going to do is we're going to create our own virtual private cloud, and that's going to be the next 45 minutes, right? And then you're going to create 2 public subnets, 2 private subnets, and you're going to create one for each availability zone. And you're going to create an application server and a security group and launch an EC2 instance. Now, if you're logged into webh.quicklabs.com, right, and you click on My Learnings and then click on the Tech Essentials class, you'll see the first lab is now active and open. And if you click Start Lab in that upper left-hand side, what will happen is that you can then follow the directions for your first task, which is create your VPC. Now be aware, when you say start lab, it will start a timer. They give you more than double the time necessary because this lab is only a 45-minute lab at most. So they give you more than the time necessary. But you're going to basically create a VPC using the Launch VPC wizard. Then you're going to create additional subnets, create your VPC security group, then launch a web server, access it once it's up, and then that's it. The lab's over. Once you're done with the lab, please make sure that you log out and close any AWS tabs that you have open, because you're going to get new login credentials every time you run a lab. So 3 times today, you're going to get new login credentials. And you don't have to stop the lab or do anything to it. When the timer expires, it's going to close down. But this is where we're going to be for, you're going to work through the lab for the next 45 minutes. Any questions about this?
Yeah, okay, so if you go to My Learning, you're supposed to have this pop up?
So yes, so when you go to My Learning, you should see a class that says AWS Tech Essentials.
I have a, you don't have history yet.
The same here.
Yep, same issue with both of them too.
Yeah.
Let's see here. Let's see, and that was Fahim, Paul, and who was the other person?
Me, Jigger.
Jigger. Hi. Let's see. I see that you're enrolled and you're logged in using Jigar.bot.
Yep.
Good. So let's see.
I have
Paul,
the same issue.
Paul, could you share your screen for me really quick?
Sure. I think you got us, okay.
Oh yeah,
Yeah,
let me stop. Yep, I gotta
yeah.
stop.
Okay. So here I am, welcome Paul, so it recognizes me. And I just get that.
Okay, cool. Can you go up top and type in webage.quicklabs.com for me?
Here?
Yep.
WebH,
Webage, yeah.
sorry, WebAge.
.quicklabs.com. Sorry, it's QWIK. And you take the C out. Yeah, there we go. Just press enter. Okay, so click on sign in on the upper right hand side.
Okay.
Paul, how do you say your last name?
Very carefully.
That's funny.
Oh,
Okay. So
Didn't like it.
this may be true for the others as well. Please make sure that you're under webage.quicklabs.com, not www or Amazon or run.quicklabs.com. But it looks like it doesn't recognize your username and password. Click
Well,
on.
I noticed something. Sorry to interrupt, Michael, but I noticed that, and I'm slightly reassured that Paul also misspells his own surname.
no way.
No, I also got the same error.
Okay. So for those of you who got the invalid email or password, click on forgot password and recover based on, like, and you can see on my screen the emails that were registered. They all look like Sun Life emails. So sometimes people put their personal emails in there, which is why I'm showing it.
I'm still trying. I'm waiting to see if you can say his last name.
Well,
Because none of us can.
I'm still waiting for him to say it.
Sure, Renivietsky.
Oh, wow.
Yeah.
Wow.
You
Yeah,
asked.
we can't say it either.
Wow.
Who's going to?
And we've been around for a while.
Wait, Hernie Wieski. Is that it?
Uh,
Wieski? Yeah.
I'll let it
Without-
pass.
Yeah, without the Polish twang to it.
Yeah, it had some twang, definitely.
I just say Paul Wayne Gretzky.
I mean, I have a friend, Justin Zakreski, who has like 3 Z's in his name. And I think he's also of Polish descent, if that's true.
The ski Gazeroy. All right, so forgot password then, right? Okay.
Yeah, so forgot password. So then that should get you in, but you have to be at webage.quicklabs.com. So it looked like you probably weren't seeing, it looked like you were logged into the public site, actually.
Okay.
I
So
see
I
it now.
I did the same thing in the morning, and I'm still waiting for that forget password, reset password email.
Okay, and you checked obviously you checked your junk mail filters and all those other pieces.
Correct.
Yeah, mine is working now. Yeah,
There we go.
I can see the technical training.
Okay, I'm gonna stop, Paul, if that's okay. I'll stop your sharing.
That's fine.
Okay, good. Let's see. So who else? Sorry, who else was stuck? Who was waiting for the morning to get there? Was that Fahim?
Killian
there.
here, having issues logging in, password issues. Says there's
Okay.
an account, but password not recognized.
Okay, and you can do the password reset to reset your password if it's not working.
I'll try that now, yeah.
Yeah,
I
good.
just wasn't sure if it had been emailed to me.
Let's see, who said that they did not get an email from the system and they actually sent it in this morning?
I did, but and then I finally got one. I think I might have misspelled the email for some reason. So,
Okay.
but I was able to get into the Quick Labs, but then, well, I guess we might as well wait until everyone's in first because it's saying to start the, click Start Lab, but I'm not sure where that Start Lab is.
So if you click on My Learnings and then click on the classroom, you'll see the lab listed there. And so, by the way, if you have access, go ahead and start. We don't have to do this in lockstep. Everyone can just go. So if you hit the start button, it should say provisioning lab resources. It might flash it really quick, and then it'll start showing the console on the lower left-hand side. Sorry, upper left-hand side. And then from there, you can actually just start following the instructions, starting with task one.
Yeah, I'm still not sure where I'm supposed to be doing this, but
Okay. You want to share your screen, Glenn?
okay. So basically I got this right here. So
Okay.
now from where do I go?
You have to click Start Lab. at the
Oh,
top.
sorry.
If you-
Here's
if you
another
scroll
interesting
up.
thing. Are you are you running Chrome or Firefox?
This is actually on Edge, so I guess I have to
It
go to
typically
Chrome.
won't work on Edge. It has to be done inside of Chrome or Firefox.
Okay.
Yeah, sorry. I forgot to mention that. And what happens is they just won't load it won't load any of the CSS or the JavaScript properly. I'm not going to ask you how to pronounce your last name, but it seems pretty straightforward.
Yeah. Oh, some people screw it up.
Wait, just to check, there's no .com after Sun Life?
There is.
Oh yeah. Okay.
Good. And then there you see the start button. Click on start. It'll go.
Okay.
So, and it's going to open you into its own dedicated console. Like, so you're going to have your own AWS account for a second.
Yeah.
So yeah, so you should be good from there. Then.
Okay. All right,
Yeah.
thanks.
All right.
Sorry,
Who
I'm the
else?
only one.
All right, Fahim, talk to me. So what are we missing? So you didn't get the email from earlier for the reset?
No, not yet.
Okay. Is there any chance that it could have gone into any other folder? And I'm assuming you searched everything.
Because in the morning when I had an issue for confirming my email, I got an email at 9:11. I can show my screen and I'll
Yeah,
show you
please.
what it is.
Let's do it. Let's troubleshoot it. Okay, so did you already confirm that email because it basically says that
So
it's-
this email I got in today, 9/11.
Okay, so just to
Yeah,
be clear,
so-
you're at www.quicklabs.com, not WebAge.
Yes, okay, here,
So make sure you switch over to WebAge.
yeah. And then when I'm trying to enter,
Fahim, I can't see your movement. Are you on a second screen? I can't see anything other than,
one second, I think. Okay, so this is.
there we go. Okay. So webage.quicklabs.com, good, okay. And then let's see. Okay, and then when you did forget password here, what did it do?
They want me to enter my email address.
Could you do it? Yeah, do it again for me, just for giggles. Although I don't know how funny it is, but we'll do it anyway. All right, then send me reset instructions.
And
And you already verified your account, correct? Yep,
yeah,
there it is.
yeah.
Yeah, confirm. your
this was
address.
in the morning, and I'm still waiting for an. Okay, now I got it.
There we go. Good. Yeah, you just put in your new password, log in with it, and it should work. There you go. Yeah, so click on My Learning, and then you should see the tech class. Yep, and then you go. You just click on that first lab, the one at the top. Just click the name. And then click Start Lab, and you're good to go.
Okay, thank you.
Awesome. I'll stop sharing. All right. For those of you who already started, keep going. For those of you who are just getting started, we got plenty of time. So you're going to do this until noon. And then when you get done, you're done. You can go take lunch, take a break, do whatever you want, or you can ask me questions, whichever you want to do. We're going to resume at 10 till, so 12:50 my time. So we're going to resume at 10 till the hour after we're done. Otherwise, just keep going. If you have any questions, let me know. I'm here. So in relation to storage, there are a bevy of storage services, but not as many as there are in other sections. So, you know, Amazon has block storage, they have object storage, they have file storage. And don't get me wrong, all of this is network enabled. So even the direct attached block storage is really actually iSCSI based, so it's across the network. If it's file storage, it's either going to be NFS or CIFS or SMB, right, across the network. And object storage is just a remote storage system, meaning you're actually just putting objects in their entirety or reading them out of their entirety in and out of a remote system. Kind of like thinking about like a remote system, almost like a Dropbox or a Google Drive or a OneDrive. Just like you're putting it out there, you can pull it down, you can get a copy of it, but it exists somewhere else, not on the local operating system. So with S3, that's pure object storage. So this is just storage for the internet. Natively, it grants online HTTP access. By default, everything that is locked down. So S3 is great when you have a large distribution of files that are up to 5 terabytes in size. And the amount of data you can put out here is limited only by what you will pay for. I think back in 2014, I had 3.2 petabytes of videos actually out here on S3. The capabilities of this system have only grown in the last 8 years. It's highly scalable, very durable, 11 nines of durability. So it'll take them 100 years to lose like one of your 10,000 files or some variation thereof. But it allows you to just dump a large swath of files like log files, data files of any type, whether they're in different formats or CSV, TSV delineated. And it's great. And it also can host websites, and you can actually SFTP into S3 as well. So you can enable that. And it used to, I know this is shocking. I just found out that they're retiring, that it used to support BitTorrent. I was like, I didn't even know that. But it's really an unlimited scalable object storage system. This is API storage. You do not mount this in your operating system. You either put files on it, pull files off of it, or list files that are on it. That's it. They work off of the concept of buckets, and all data is encrypted in transit by default, but you can encrypt it at rest as well if you want to, either using your own certificate, like own keys, or you can use KMS managed keys, or on the server side. So there's actually 3 kind of encryption options. This is a really kind of powerful tool, which is why I often joke about it being the gateway tool to get into AWS, is that this tool will give you entry into the whole AWS ecosystem. You can also make it so that when buckets are written to, let's say a file, it triggers a response by some other system inside of AWS. And that can be like a web post. You can call Lambda. It could trigger an audit. It could trigger a notification. It can trigger all kinds of stuff. Mainly S3 is used for just as the de facto storage system inside of AWS because it's so cheap and it's so scalable. The only time you start looking at disks to typically host on an EC2 instance, as an example, is if you actually need fast direct attached storage. Typically, otherwise, the de facto system for storing things is typically S3 in most architectures. And S3 lends itself really well to event-driven architectures where you've got a task that triggers another task that triggers another task. So, people make data lakes out of S3. They just put their data out there and they use the various tools to query the data while it's out on S3 instead of having to load it into a data warehouse. When you make snapshots and AMIs, by default, they're actually stored in a hidden section of S3 for you. You can't really get to it from the S3 interface, but this is where most of the AMIs and backups are stored most. This is where all the AMIs and backups are stored. So the concept here is that you've got something that looks like a high-level folder called a bucket. Buckets have a home base that's regionally based. They are highly redundant, both with each other, intra-region and inter-region. And in that bucket, you've got objects, and it looks like it's a file system, but actually each object just has a prefix set of folders. And so what looks like folders as you're traversing through it is actually just a bunch of prefixes attached to an object. So an object, by the way, can be anything: MP3, MP4, JPEG, a Word doc. It can be anything you want. If we go look actually at S3 in my accounts, you'll notice that I have a home base here as far as for each of these particular buckets that I have. And I've got some odd names here because names are globally unique across all of AWS. So I've got Jenkins, or there was a new Go bucket. I don't know what joke they actually prompted that. But here's the DevOps Cyber Club, which is a weekly reading group that I run. And notice that there's doc files in here, there's JPEGs in here. And if I click on that link, it'll actually show me this particular object URL for that link. Now, if I click on that, it won't work because permissions are set to locked down. But if I come in here and let's say I want to edit the object permissions as an example, what will happen is I just click on permissions, go to edit, and then what I can do is actually come up here and click on read if I want to. Now, here's the problem. This bucket is actually blocked at the bucket level from actually providing public access. So I actually have to go to the bucket, disable permissions that block public access, and then come back to the object. So just something to be aware of is that the bucket itself has overarching permissions, and that the objects themselves in the bucket also have individual permissions. So usually bucket permissions dominate over object permissions. But if I go in here and unblock public access, I can actually still keep the entire bucket private and then come in here and make just this object public so that people can see it. I can also, by the way, add access to other AWS accounts. Because S3 is a service that predates user authentication, there's actually an older forms of auth that allow you to open things up based on account ID, right? Using access control lists or bucket policies if you want instead. So again, the way this works is that there's just buckets, and inside the buckets are various objects of various types. And so here, this looks like a folder that actually leads to a couple of other, videos and whatnot. So S3 is just used for generalized storage. So it's object storage, it's API-based storage, not mounted inside of a file system. Now, when you put an object in, so in this case, an HTML file, notice that the bucket name is going to be the first thing that you see. So if we go back to what we were looking at before, and I go back to DevOps Cyber Club, if we go look at this object URL, notice that the first part of that object URL is actually DevOps Cyber Club. That's the bucket name. And then you'll see the object is just listed at the end. It's exactly like this. The bucket's at the beginning, and if there's any prefix folders, they are actually suffixes on the URL, and it ends with the object in question. This, by the way, is why the bucket names are unique, because there's no other differentiator or modifier here, right? There's nothing to actually say that this is somebody's specific account. That doc.s3.amazonaws.com is unique globally. And so that happens as a result of the name that you choose when you create the bucket. I mentioned before that data at rest and data in transit can be encrypted. When you use SDKs or any of the official tools, it's encrypted by default. You can use IAM policies, bucket policies, or access control lists to control access to S3. It is usually recommended that you use IAM policies because that's the more modern derivation, but there are rare use cases to use, for example, bucket policies. You can also turn on versioning. Like if you don't want someone to accidentally overwrite your file, you can also lock it if you want, make it so that nobody can make changes to it. But you can also create a version history of every single change made to a file. And what happens is it just copies the entirety of the file. So if you have a 100 meg file, make a change to it, you get another 100 meg file as a copy. And so you can actually have multiple copies of a file. They call them versions. And even deletion is just another version of the file. If you actually want to delete this file and it's got versioning enabled, you have to delete all of the versions and the delete marker. Objects also can have a life cycle in addition to versioning, which means that you can actually move them to colder tiers of storage. S3 is probably standard, is the hottest tier of storage, meaning it's the fastest. But there's about 6 tiers of storage that go colder from standard S3, including infrequent access one zone, S3. There's Glacier and there's Glacier Deep Archive. So you can actually have automatic rule sets to say, look, after 30 days, I want you to move down to infrequent access. And after another 30 days, I want you to move down to Glacier. And after that, I want you to move into Deep Archive. And after that, I want you to delete. So you can set up these lifecycle rules or policies inside your S3 buckets to control what happens with objects inside these buckets. Now, S3 is cool in that you pay for what you use in terms of space, and you pay for what you've changed. So if you go in and put in new copies of files or whatnot, there's a little bit of a charge for every time you make a change to a file. It's not very much. If we were to go out, for example, and look at the AWS Simple Monthly Calculator, the AWS Simple Monthly Calculator is, by the way, slated to be retired, just so you're aware. So I'll also talk about another tool. But if I click over to S3 on the left-hand side, and let's say I want a terabyte of storage per month, and I want to make let's see, maybe make 100 changes to it. But I'm gonna do read it 1,000 times, 10-to-1 ratio. It's not bad. You'll notice that that equates to about $23 a month on the hot side. If I go to one of the colder tiers of storage and I don't do a terabyte, and instead I decide I want to put it, just lock it down into an archival of compliance storage. If you go over to Deep Archive, which is the coldest tier of storage that you can get, and you just leave it alone for the 6 months required, notice that you're going to spend $1. So the file is still there, or the object or whatever, the bucket's still there, but it's actually in a vault. And so that's what Deep Archive is, and that's why it costs $1. is it's going to stay there for 6 months, and you can pull it out at any time if you want to pay a retrieval fee. It'll then restore itself into S3. But once it's in Glacier or Glacier Deep Archive, it's actually in Vault at that point, which means it cannot be directly accessed. Any of the other tiers of S3, like standard, infrequent access, reduced redundancy, that kind of thing, that is all still accessible. It's accessible at a slightly slower speed. But Vault, the file is not directly accessible. So anything in the Glacier, either in Glacier or Glacier Deep Archive, is actually locked away in a Vault. You just have to restore it if you want it. But notice the scaling of pricing there. It's basically 1/23, right, of the full cost. All right. Glacier, which I was just talking about, is the archival storage. It's got 2 flavors, Glacier Standard and Glacier Deep Archive. Just note that it has the same 11 nines of durability that standard S3 has. When you want to retrieve something from the Glacier vaults, it takes 3 to 5 hours in standard to start that process. And it will restore into S3, just so you know, but it's typically really, really cheap. Deep Archive is the same way. The only problem is that with Deep Archive, the file has to sit there for 6 months before you try to pull it out, or you have to pay an expeditious retrieval fee, an expedited retrieval fee. Sorry, not an expeditious. Just making up words over here. All right. So here are some of the storage classes from hot to cold. There's standard, there's infrequent access, and then there's one zone infrequent access, which you would think it would actually reduce like the resiliency, like or SLA of some type. And it does reduce availability, but durability stays strong, right? And so that's 3 of the storage classes. And then here are the other 3. Intelligent tiering, which actually uses machine learning to move your file to hot or cold storage depending on its access pattern. And then there's Glacier and Glacier Deep Archive. So intelligent tiering isn't really like a mid-tier cold storage solution. You want to use intelligent tiering when you have no idea what the access pattern is, but you do know that you want it to try and be as cheap as possible. So intelligent tiering takes care of that for you by automatically managing whether your storage is classified as hot or classified as cold based on its access pattern. Note that it says there that restoring objects with Glacier can take up to 1 minute to 5 hours. It's actually 3 to 5 hours standard. If you want to pay an expedition fee, an expedite fee, I'm just making up words around expedite today. If you want to pay an expedition fee or an expedite fee, you can get that down to 3 to 5 minutes. The fee is like 50 cents or something. But if you do that 100 times, you're obviously going to see some impact. Wait, will you? $500, maybe. Let's see. I think we already looked at S3. But does anybody have any questions about that? Anything anybody wanted to see around S3? Probably pretty familiar with it. I just want to check. Good. All right. Let's talk about EBS then. So EBS, if S3 is object API driven storage to a remote system, EBS is intimate, like connected hard drives. Think of this as like USB or SCSI drives, SAS drives, SATA drives attached to your system. That's really what EBS is. EBS only works with EC2. So, don't be fooled. S3 doesn't need EC2 to function. S3 is an independent storage system that you can just call through APIs. EBS is actually attaching hard drives to your EC2 instances. So it is intricately tied with EC2 because it doesn't function without it. There's no other way to access the data on an EBS volume unless you mount it inside of an operating system. So this is persistent block level storage that offers like really low latency performance, and it is actually tied to an availability zone. So it's not regional. It's tied to a specific availability zone because virtual machines are tied to a specific availability zone. So they operate the same way virtual machines do. You can snapshot them and take backups. Obviously, those snapshots are stored in a hidden portion of S3, but that's specific for EBS. You've probably seen this before, but once you create a drive, you have to attach it to a system while it's in use. And then you can create a snapshot, which you can do to the running system if you want to. And then you want to detach it when you want to take it off the system. Of course, you can delete it from that point in time. Do note that you are capped at 16 terabytes per volume, and that typically there's a performance ratio between the number of gigabytes in terms of size. It's usually about 3 IO per gigabyte with some burstability there. Now you've got two families of these systems, right? You've got the SSD backed ones, excuse me, and you've got the hard drive, like the mechanical backed ones. There's two each. There's the general purpose series for SSDs, and then there's the provisioned IOPS series for SSDs. Throughput and cold storage are what exist in the mechanical side of things. And they're usually measured in like MB, while SSD backed systems are usually measured in IOPS. So this is slightly out of date in that it's actually GP3 and IO2 now, because there's now new versions of storage. First time Amazon's done that since EBS has been released. The new versions of storage are faster and cheaper per gigabyte than the previous versions. And you can't upgrade from GP2 to GP3, for example, on the fly. So you'll notice that there's general purpose storage, what we call GP2 or GP3. There's provisioned IOPS storage, which is IO1, also IO2, because that's the new one. And then we have throughput optimized and cold hard drives, which is ST1 and SC1 on the two right-hand side options. Notice that all of them cap out at 16 terabytes max, although their minimums are just slightly different. But in general, you're going to use GP2 and GP3 for most of your workloads, because that's going to handle most of your scenarios, your use cases. Provisioned IOPS is really used when you have like a write-heavy application like a database, and you need to guarantee IO performance. I'm going to pull this off the top of my head, so it might be a little fudged. But if I remember correctly, GP3 now goes to 32,000 IOPS on the general purpose side. It was 16 and it got bumped. And then provisioned IOPS went from 64 to one. Is that right? No, they were at 32 and they went to 64. 64,000 IOPS a second. There's actually a new version of provisioned IOPS called Block Express coming out that goes to 256,000 IO per second. So these are really fast hard drives. That's the main thing to take away from this, because these chunk sizes are typically 256K, which is larger than most systems. The throughput optimized and the cold systems, they're not really pushing for IOPS. They will do large transfer rates from a disk perspective, but really these are archival systems from my perspective. When in doubt, use GP3 as your disk type, because it's going to accommodate most of your use cases and it's going to do so cheaply. So just remember that EBS is recommended over instant storage, and you can add multiple hard drives to the same instance. Now, it used to be that you couldn't attach a single EBS hard drive or volume to more than one operating system at a time. But just last year, someone got a wild hair and decided to create what they call multi-attach EBS. So just so you know, if you have a cluster file system on your system and you want to share a disk in the same availability zone with two different operating systems, you can. It's not recommended. So make sure you have a very purposeful use case if you're going to do that. You can dynamically change volume size. You can convert over to provisioned IOPS for an existing disk. And you can also convert types in some cases from a SSD to HDD. Please test that before you actually do it. Most of the time it works flawlessly. Sometimes in certain use cases it goes sideways. You can launch, by the way, EBS volumes as encrypted. If you launch them as encrypted and you take a snapshot, the snapshot's encrypted. And if you launch another copy of that snapshot into another availability zone, it's going to be encrypted as well. So just know that you have to de-encrypt a disk and then snapshot it if you want your backups to be decrypted. Let's see. Obviously, whatever you need a hard drive for is a great use case. So, whatever you need a hard drive for. Just, match the type of hard drive to the workload and you're good to go. Let's see, EBS pricing is usually like a factor of how big is the disk, what type is the disk, and if you're using provisioned IOPS, what did you turn the dial on and say, I want to set the IOPS to this? Like if you want to set performance at a certain level with the provisioned IOPS volume, you're going to pay for that. If the number's higher, you're going to pay less for it if the number's lower. If we look at this actually in the simple monthly calculator, we actually remove our previous 1 terabyte entry. If we go up here actually to EC2, underneath there, they actually have what they did. Here it is, EBS volume section. And so what you can do is you can actually come up here and add, like, for example, GP3 and say, look, I want, a terabyte of disk space. And you're not necessarily going to change anything else because it's just GP general purpose. And notice that it's going to be $80 for that hard drive. Notice that that's way more expensive than the $23 you're going to pay for S3. Right? So remember, if you don't need a direct attached disk, S3 is going to be way cheaper for you and it's going to scale way better. But if you need single disk performance, it's going to perform like crazy, then you're going to need to pay that $80 or whatever to get the disk in question. Okay. Oh, I'm just going to post that out actually. Let me post this in chat. If you want access to the calculator to mess around. Calculator is cool because it actually teaches you the dimensions of pricing, because nobody memorizes that. And there's actually another one, AWS.calculator, that's out there as well that they're working on to try and get feature parity. So there's another one called AWS.calculator. Is that calculator? Yeah, is that right? Oh, sorry, calculator.aws. I got it backwards. There's another one that actually allows you to create visible estimates that you can save to your account, which is pretty cool. So if you need to price out a project, you can do that. That has multiple services attached to it. Okay. Oh, do recemember that EBS volumes are in a single availability zone, so they don't go across a region. You have to pull them out as snapshots and then recreate them into a new zone with the same data. So just remember that. Again, just some clarity about S3 versus EBS. Remember, S3 is a remote object storage system that is not mountable inside of an operating system. It can serve out any number of systems that want to make API calls to it. EBS is specifically a hard drive service. So just keep that in mind. EBS cannot be accessed from the internet unless the EC2 instance somehow shares the file system. So it's basically a disk drive. That's all it is. Okay, just pausing for questions for a second. All right. Remember, we talked before. Oh God, it wasn't 385, it was 365. Sorry, I was off earlier. That there is instant storage available with some of these EC2 instance types. Be very careful with that because you will lose it if it goes down, right? There's no persistence of this data. So automatic data deletion with no chance of recovery if the instance stops, fails, or is terminated. So just know that it's there for scratch. It's there for you to mess around. It's not there for production workloads. So. And so just as a quick comparison, EBS is persistent outside the lifecycle of the EC2 instance, especially if delete on termination is not set to true. But instant storage is ephemeral regardless. You also pay for EBS. You don't pay for instant storage. There's a little chart here about what happens to like various aspects of EC2 components when you basically either reboot, stop or start, or terminate. They call it end, but I guess we're changing it. Maybe we're using a different language now. End. Notice that you know, for the most part, for a reboot, nothing really changes actually, right? If you have an associated IP address, it stays with it. If you have EBS volumes, they're not really touched, right? If you stop an instance, what happens is if you're stopping it, you're not actually deleting the virtual machine, you're just telling it to power off. Really, for the most part, nothing changes, right? But I will tell you that when you start that system back up, or you reboot it, it actually is going to start on a different backend hypervisor host. So just so you know, the reason Amazon will ask you to reboot systems is because they're asking you to move to a different host because they're about to do maintenance on it. So you will get notifications to reboot your host for that reason, like once a year, once every couple of years.
Are they gonna ever have where they can move it off of the host without causing an outage?
No. You mean live migration?
Yeah, because we're having that problem where they keep emailing us and the clients are getting pissed because they're asking them over and over again to move it to another host. So we have to keep bringing down the instance so they can move it over to so when it boots back up, it boots on a new host. And they have to do it multiple times in a month because of it, and they're not too happy.
Yeah, and the problem, Glenn, is that best practices is that for like customer-facing workloads, you're supposed to have 2 instances, and I know that's not always possible, right? Because it just depends on the use case and the architecture. But and then they ask you to run 2 instances with a load balancer, so that if one needs to be rebooted, it won't disrupt the client experience. But that's not always possible. What if it's a database, right? You can't always get away with that.
Yeah.
But I've had a conversation with them about live migration several times because that's been a key VMware feature for years, right? And it's not something that they say their customers are asking for. I was like, well, who are you talking to?
I know. I know we've been asking for it. So
yeah, I'm like, who are you talking to? Because I can point you to people to talk to, right? Yeah. So thus far, I don't see. I have never seen it on the EC2 roadmap to do live migration. Yeah, and I know the pain of that because, there's always instances that you actually can't reboot easily or recreate easily, for that matter. So when you reboot something, it does start on a new host system. Now you can't even you can't stop and start an instance that has an EBS backed volume, right? If it's an EBS backed instance and you don't even have an option to start it, because if you start it, you're going to lose your data. So the only options if it's EBS backed is actually to either terminate it or just do a quick reboot on it. So just know that whole stop start process does put you on a new host, but you can't even do that with EBS backed instances. So your only option is actually to snapshot it and terminate it. If you end a box, like if you say, look, I want to terminate a box, anything associated with that box usually is either deleted or disassociated. So if you've added a public IP address to a box and then you say, I want this box to go away, anything associated with it gets released. Be mindful of that, because if you bought an Elastic IP, if you requested an Elastic IP, they're free as long as they're attached to a host. If all of a sudden a bunch of Elastic IP addresses are unattached to a host, they'll charge you like 50 cents a month or something for an IPv4 address. Do note that the minute you either tell a system to stop or you tell a system to terminate, that's when your billing stops. So the minute it's been told to stop is the minute you stop incurring billing charges. So some people ask, do I have to wait for it to shut down? What if it takes 10 minutes to shut down? The minute you tell it to stop or terminate, it stops your billing charges. All right, little quick knowledge check here. Before we do this, are there any questions about anything that I just went over? Because that could have been a lot, especially right after lunch. Okay. All right, so which AWS service actually would help support a web application by hosting static web assets and storing user uploaded images and videos off of an EC2 instance? So if we go back, one of the great uses for S3 is to actually host static assets. So if you want to actually store your images and other things that don't require processing by a processor off of the instance because you want to save horsepower or sizing of the instance, you can actually just put that on S3, just change DNS to point to the bucket in question, and then you can just grab your static assets for the web page. It can just pull those off the S3 bucket while your web server handles all your dynamic content processing. So it's a great way to save horsepower on web servers, is just allow S3 to host those static objects. You can even enable cross-origin resource sharing if you need to, and whatever like type or definition you need to control who can actually pull those things down. So S3 is a great option for that. If you were on an EC2 instance and you didn't have access to the console, how would you basically get the public and private IP addresses off the system?
Well, that would be down in the lower, when you select the instance in the lower tabs, you can look in the addresses down there, right? In the, I don't have it in front of me, but
What if you didn't have access to the console? What if someone just gave you an instance and you were writing a script for it and you needed to see the public and private IP addresses? How would you find that off the system? Not using Linux commands either, per se, right? Like ifconfig and whatnot, or ipconfig.
Using the URL,
Good. Sure. What kind of URL are we talking about?
the curl or the get command will get that for you.
What's the IP address that we're looking at? Do you remember?
Begins with 169.254. Yeah.
That's it. Yeah, and it actually just repeats that. So it's just a 169.254, 169.254 / latest / metadata. If I wanted to get user data off of that, what would I replace there?
Oh, so that was just for the metadata. Yeah.
Right. If I wanted to get user data, what would I change there? And that's open to anybody, not just you, Jerry.
Mm-hmm.
So in this case, I would just change meta to user, and it would give me the commands that it was told upon first boot to run. So you can actually
Same
like,
URL,
get those.
just
Change that URL.
Okay.
Yeah. So you just run a curl, by the way, against everything from HTTP to metadata or HTTP to user data. So just curl, get that. You can actually add specific attributes to the end once you see the list, like AMI-ID or private-IP address. Like you can add then the options that you want at that point. So you can actually retrieve specific key values inside of that URL. Okay. You may remember from our whole networking conversation, there was this whole flow of when things come in from the internet, they then have to get past 2 firewalls. What acts as an additional layer of security at the subnet level in a VPC? So which of the firewalls exists at a subnet level?
There was a NAT gateway in there.
Well, the NAT gateway is used for outbound access, but you're
Right.
headed in the right direction because there's definitely something that is network oriented that acts as a control, if you will, for the subnet boundary. And it's actually a pretty popular term just in networking in general. So it's not security groups because those are stateful firewalls. What's the other firewall in AWS?
ACL.
That's right, NACLs, right? NACLs, right? Absolutely. Network access control lists. Now, don't get me wrong. There are other firewalls. Like there's web application firewalls for layer 7 filtering. There's also like other firewalls that AWS controls around the perimeter for the internet gateways. But the 3 that we mainly have access to, it's security groups, network access control lists. And if you're running a web application firewall, that can also be another firewall, but that's not a perimeter firewall per se. That's application specific. Okay, network ACLs, that's the answer. Okay, this is I truly believe that this is a marketing question. Amazon S3 limits the total amount of customer data, data a customer can store. Is that true or false? Does Amazon only allow you to put a certain amount of data in S3?
If they don't like money.
That's right. No, Amazon does like money. You're totally right. And since they're north of $50 billion now here, just AWS alone, obviously, no, this is like a marketing thing. Amazon does not limit the total amount of data you can stick into S3. You can stick any amount of data you want. So if you ever see Michael Forrester has suddenly won the lottery, because that would be the only reason I would really waste money like that, I would probably come over here and challenge that assertion. How does 1,000 petabytes sound? How about an exabyte, Amazon? What do you say now? How's your storage system doing? Unfortunately, by the way, they do a lot of dedupe on the back end, so I'd have to figure out how to create, dump a bunch of unique data, but I'm sure that would be easily figured out. Okay, that was the storage subsystem. Questions of any type around EC2 and all of its different families, VPCs and some of the components that we talked about, and the storage subsystems, particularly S3 and EBS. No? Okay. So now we're really just going to talk about IAM, which, this is a relatively kind of short conversation because it's really just users and groups and roles that have policies attached to them that have permissions inside of those policies. That's it. Don't get me wrong. IAM, which is the premier service for security for AWS as far as access, can federate with Active Directory. It can hook into Okta, Ping federated. It's OIDC and SAML compliant, so it can hook into any identity provider you want to hook it into. And just note that really at the end of the day, it comes down to users and groups and their permissions, as well as roles, which roles are just temporary sets of permissions, which we'll talk about. So let's talk about the shared responsibility model first, so you can understand where Amazon understands the line, the line of security. So typically AWS says, look, if you don't know where it's at, you can't configure it, and you don't have access to it, you're not responsible for it. So if you don't know where our data centers are, and you start a managed service with us, and we're running servers that you can't log into because you can't even see them, you're not responsible for any of that. If you run a load balancer and the only thing you can do is configure the load balancer, but you can't log into the load balancer, you can't get access to the logs, you can't patch the load balancer, well, then the only thing you're responsible for are the things that you can configure on the load balancer. But you're not responsible for the load balancer itself because you can't do anything with the load balancer. So it didn't really matter, right? In terms of security, you just are responsible for the things that you can control and you can log into. We'll take care of everything else because we control it, we can log into it. Now, I will tell you that doesn't mean that Amazon's not transparent about their certifications and attestations. They have more certifications, security certifications, both nationally and globally than any other company other than other infrastructure providers that I've ever heard of, actually. And the number one reason for that is that was the number one objection against cloud back in 2006, 2007, 8, was that why would I give somebody else my data? But to date, they have not had a significant breach of any type against their infrastructure, which is amazing considering how many people are trying to get in here. They have had customers mess around with systems, and they've had one or two kind of cautionary flags where an employee was cited as trying to get into something, but all their controls and processes prevented that from happening, right? So just know that to date, there has been no significant breach around AWS services that would cause people to lose trust in their security capability. Because I got to say, when that happens, this whole cloud thing is going to come into question, right, to a certain degree. Now, that being said, if you were looking at a service and you're going, I wonder if from an audit perspective, if I'm responsible for this, it really comes down to if it's data that you've put into the system, that's going to be your responsibility. Now, if you have a checkbox to check encryption and you don't check it, that's also going to be your responsibility. But if Amazon tells you by default that you stick data in here, it's encrypted, then they have to provide evidence of that encryption in some form or fashion. And I've been through 2 audits, really 2.5, with AWS around like attaining certain certifications like ISO 27001. And they're really good partners when it comes to auditing and security attestations. But the bottom line is that if you can configure it and you have access to it, then you're responsible for the security of it. Everything else is AWS's responsibility, and they do a really good job of it. So they do have physical security on other data centers, and if you're in GovCloud, things get even more stringent because they do have government data centers. They also have a CIA data center. I don't even want to know, honestly. So they've got like different levels of data centers. The GovCloud one and the public one are definitely like free for consumption. The GovCloud one you can only get into if you have a relationship with either a government agency or you're one of those contracting parties. The data centers are scattered all over the world. People say they don't know where they're at, but oddly enough, there's quite a few that can show up in Google Maps if you're really looking for one. And they follow a lot more physical security protocols than what's just listed here. They are really good about learning from mistakes. So when they do have outages and stuff like that, which actually haven't had any really like global outages in a while, they're really good about making that work. They also provide a host of tools for you to stay protected and connected. And of course, everything's API driven. So any of your other tools that can interface with that API or even tap into the network, they can provide access to that. So they have these things called gateway load balancers now that actually are kind of in tap networks. So you can actually do like deep packet inspection and firewalls and stuff in line, in between your production traffic and whatnot. So they really are trying to enable a secure internet. They're really trying to make that work as much as possible, both in their enterprise and in some of their open source contributions. They do require encryption in transit for all of their interactions, including using the SDK, the command line, the web console. They have obviously security groups and NACLs, which are their stateful and stateless firewalls. And of course, you've got network control with both private and public subnets, as well as control the route tables inside of your particular like virtual private cloud. Security groups, by the way, can be chained together. So you can actually refer to the members of another security group as being authorized for access to this security group. And you can get very granular with ICMP and UDP and TCP and whatnot to really make it so that only very specific IP port combinations from certain IP port combinations or hosts are allowed, right, with certain protocols. So get very granular with your firewalls. And then with VPC, this is where IAM comes in, because identity access management is the premier service for basically managing users and federating inside of AWS. So this is where you control how users get permissions. This is how you grant them roles to access, for example, other accounts. And this is how you federate with things like Active Directory. It used to be, by the way, that you couldn't use IAM for anything other than AWS access. Some people have figured out ways to extend IAM into databases. So you can actually use IAM credentials to get access to your SQL engines, as well as into operating systems as well. But most of the time, people federate against Active Directory or some other kind of Kerberos-based system to actually make that work. Authentication with IAM is really interesting because, like, to give you an example, we go back to my setup, for example, and I'm just going to log out for a second. If I log in to my account with an email address, that is signing in as the root user. That's the owner of the account. It cannot be restricted, and it's typically recommended that you never do that after you create your first user. For most enterprises, that isn't a problem because we don't even have access to that, right? But if you are running as an IAM user, you'll have to either have an account alias or your account number in order to get into an account. And then from there, what happens is that you just log in using an IAM username. So this is a user that's not the owner of the account. It's actually a user in the IAM service that has permissions to log in. In this particular case, I forgot about MFA, but I'm glad I have it because that means I'm doing the right thing. Obviously, multi-factor authentication can be enabled to get access. Let's see. And so there you are, and I'm actually logged in. And if I go into IAM, because you notice I was logged in as Spartan Sage, which is what my 13-year-old calls me. What happens is if we go in here and look, there's a couple of different like users for this demo account, including my Terraform user, my Jenkins user, and then a couple of, like a website that I have read-only access for. But here's Spartan Sage. And if I click into this is in the user side of things. Notice that I actually have policies attached directly to my user. And I'm also a member of a number of groups that also have permissions attached to them. In here, by the way, are other things like how I would find out my console password if I wanted to reset it, or how I would manage my two-factor MFA device. If I had any certificates, they would be listed here as well. And notice that here are some access keys, of which this is the user portion. And there's like a secrets portion that you get when you actually make the access key. These can be made inactive or revoked. The access keys, by the way, if you notice, see how it says PBOH? If I actually switch over to one of my terminals and I run the command line, if you run AWS configure, see how it says PBOH? The rest of it's all masked out, right? So you can see how that matches one of the keys here is there's a PBOH right here. That's the primary key for this particular system. Now, you need access keys in order to allow command line and SDKs like Python and .NET and whatever. If they're not on premise, like on the cloud, you have to give them keys in order for them to represent you either through the command line or through an application. So like, for example, if I do an AWS EC2, let's say I want to describe instances, for example, and I just want to list anything that I have running, which currently I don't actually have anything running. Or if I wanted to list all my S3 buckets, notice that it didn't ask me for any username and password. Just so you're aware, and you may already know this, is that there's actually a .aws directory in my home directory that actually contains my credentials. It also happens to have a Terraform file in it. Just leave that there, right? And then some configuration about whether I'm outputting YAML or JSON or whatnot. That all predicates on an access key that is tied to a particular user. Now, whether this user is an actual user or if it's an application user is up to you. But just to say this is that if I was running this system on AWS infrastructure, I wouldn't have to give this system, I wouldn't have to give it any keys. I could give it a role instead, which is something we're going to talk about in just a second. But just note that if you're running on AWS infrastructure, you don't have to give your virtual machines or your running applications keys. You can actually just give them a role, which is assigned to the service. So you can actually give an EC2 box security context by giving it a secure, like a role, an IAM role. So to go back to our presentation, once I've logged in, you get access then to the console, right? And you saw multi-factor, no issue there. We just talked about the access key, and I just showed you what this whole slide has looked like. Is that key, and there's two parts to it. There's an access key and there's a secret access key, which is basically the password. The secret access key is the one that you don't want to share with anybody, because if they see it, they can kind of get access and a hold of your system. They can act like you and do whatever that the permissions are assigned to that user. But again, if you're on AWS infrastructure, you don't need access keys and secret keys. You can actually just use roles to assign. And AWS has been recommending that for since 2015, 2016. So you've got users that can actually be stuck in the groups. Sorry, was there a question? Someone gonna ask a question? Somebody? No? Okay. So remember that your users can go into groups. So just like it is with any system, you can actually stick users in groups. Permissions ideally are assigned to the group, and the group hopefully is descriptive, like read-only access to S3 for project A, full access to S3 for project B, like something along those lines. If it isn't, by the way, you can actually do a policy simulator that will actually tell you what this user has in terms of access to things. But this works like any other system that you want. The only thing that doesn't work like other systems is you can't stick groups inside of groups. Yeah, you can't stick groups inside of groups for whatever reason. So that's one of my favorite things to do as far as organization, but yeah. Let's see. Once you authorize, it's going to be one of these three entities: a user, a group, or a role are the three entities inside of AWS. But when you authenticate as a user, and you're either part of a group or you assume a role. So that's all based on policies that contain collections of permissions. So like in this case, if we go back and look at mine, you'll notice that in my permissions, there's an administrator access thing here. If I click on this one, by the way, and we actually look at it in detail, you'll notice that basically it says, well, Michael can do anything he wants to anything he wants, right? Basically says, I can do any action against any particular resource with no limitations. That policy is very wide open and has no granularity to it whatsoever. And it's a demo account, so that's fine, but not ideal. If we actually go into one of the groups, the user groups, and we go and look at, let's say, full read-only as an example, and let's say we want to look at the actual permission itself for read-only access, what we can do is that when we look at the JSON for this, notice that I can do like gets, lists, searches, and notice that it lists all of the APIs like Amplify, App Mesh, Audit Manager, EC2 will be in here, CloudWatch will be in here. But notice I have no modify, create, delete options. I only have get, describe, list, and lookup options. That's it. This is a really, still blanket, right? Because it's got all the services in it. But notice the only thing I can do here is actually read. I can't actually change anything. These are just permissions that are assigned inside of a policy. The policy is attached to the group or attached to the user, as you saw earlier. So here's another instance of a policy. In this particular case, you can see the action is I can describe instances. Oh, hi, sorry. You can see the action is I can describe instances, I can start instances, and I can stop instances. And I'm allowed to do it as long as this condition is met. I have to come from this specific IP address, 54.64.34.65. You can put negative conditions in there, by the way, saying, look, as long as you're not from the internet or you're not unencrypted, right? You can actually set different conditions in there. Notice that down below that there's an S3 get object API call allowed, but only against the contents of a specific bucket. Right, and so these elements combined, and notice these are allows. Notice the effect is allow, the effect is allow. If these were denies, by the way, no amount of allows would override a deny, because if there's an explicit permission-based deny, nothing will undo that permission-based deny. So people tend to focus on allows and they deny stuff they don't want anybody to ever touch, right? Like quantum computing, for example. So this policy has a set of permission set inside of it, and then this gets assigned to the users or groups in question. It can also be assigned to a role. Now you might say to me, Michael, you keep talking about roles. What are roles exactly? What are we talking about here, right? And so think of a role as a set of permissions like sudo, or when you elevate administrator in like a PowerShell or command line, or sorry, the command prompts. Like if you want to elevate permissions to administrator, you would do it temporarily, and it's just for that particular session. I also like to think of this socially, like it's like I'm a father and I'm a son and I'm a brother. So like I have a different set of societal permissions with my son where I'm like, hey buddy, your room is like really trashed. We got people coming over today. You got to clean this up, make your bed. Let me know how that works out. If you need some support, right? Something along those lines. If I said that to my mom, it's like, hey mom, your room's kind of messy. We got people coming over. If you can, let's pick all this up and get this done. I have a different set of permissions, and she'd probably honestly like pull some kind of wrestling move on me. But like the point being is that I have son permission, like a son role with her. I have a father role with my son. And of course, like with my sister, I have a brother role. Now, they're not as clearly defined as these roles, right? These roles actually say who can be that person. So when you create a role, you say who can assume the role, right? And then if they're allowed to assume the role, they can be that role, and then they get all the permissions with that role. And then when they're done, they can step it back. Now you might say, Michael, why would you do that instead of just creating another like account? Well, the problem is that let's say you've got 50 accounts to manage and you only want to create one user ID for the person. You create one user ID in account one, and the other 49 accounts, you create roles that allow that user to come into those accounts. That way you have one username and password to manage, one user to mess with, and then all the roles can just be changed as needed, but the roles are all existent in those accounts. So then that way the user doesn't have 50 username and passwords they have to remember. Roles can also be assigned to services. I mentioned this before. If you want an application running on an EC2 instance to have permissions to S3, you just give that EC2 instance a role that grants permissions to S3, and that application can actually read the temporary credentials off of that role, and it can access S3. So roles are really useful when you don't want to do duplicate work, or you want to grant like cross-account access to like other users without having duplicate user IDs or users inside of the system. So for example, if there's a Python application hosted on an EC2 instance, you can actually store the credentials on the EC2 instance, but that's not preferred. You could securely distribute through a Vault AWS credentials. That's actually not a bad idea, and actually it's pretty secure, healthy, right? But really, if it's hosted on an EC2 instance, you want to give it a role. That's really the best thing to do, is to give it a role and let it distribute that way. So here, by the way, when you're creating an instance like an EC2 virtual machine, you can actually choose the IAM role right there as a drop-down box, and you can create a new IAM role right there as well. You can also add a role to a system while it's running. By the way, that used to not be the case about 5 or 6 years ago. You had to boot a new instance every time you wanted to change the role. Thankfully, that's changed. You can actually just change roles on the fly now. No issues at all. I don't know why they call them instance profiles. I think it has something to do with the metadata piece. I don't know why they don't just call it a role profile or role for the service or whatever. But they refer to them as instance profiles. But in the interface, it's called an IAM role that you can assign. You can actually assume a role if you want to inside the console as well. I'm assuming that some of you have done this before. You can actually just switch a role. It's one of the options, right? And so if you want to switch role, you just have to pick the account that you're switching over to. It could be this account, by the way. If you're ever looking for your account number for your account, it's usually listed up here under the user tab. But if you ever, like if I needed to loop back, I think I actually have an enforced or admin. So let me see if that works really quick. I think that's right. Let's switch roles really quick. Yeah, there it is. So notice that up here, instead of being Spartan Sage at Enforcer, it's now listing Enforcer admin, giving me elevated permissions, right? Inside my own local account. That's all I did is I looped back to it. So notice that from the console, from the command line, and from the SDK, you can actually assume roles if you want to. When you're done, by the way, you can actually just switch out like back to Spartan Sage, and it will take you out of the role and put you back in the system. The reason that was set up is that I'm gonna move my user ID from my demo account to a more restricted user, not because anything happened, just because it's good practice. Okay, I think we showed this for the most part, but you might have a very restrictive policy for your user and then switch roles so you can get a more elevated policy, which is literally what I just showed you on the command line. But previously you might not have access to S3, but if you get that elevated policy, you can then get access to S3. This also, by the way, shows that you could assume a role in another account, and like to get and maybe access to another bucket, right? From account B, for example. Any questions about roles, users, or groups before we talk about the simple token service, which is what STS is? Okay. All right, so we already talked about access keys. We already talked about secret keys, but we haven't talked about session tokens, right? So STS credentials are something that you can request, and they're actually used in role context all the time. We just don't see it, right? So this allows you, by the way, to like request a token that will authenticate the user, that much like a role, and it's very similar to a role. But you can actually use this to federate with IDPs and things like Active Directory. It's actually incorporated in there as well. This is great also for mobile users and other pieces like that, where you can actually just say, look, I need a token. And do you have permissions to request that token? If you do, you can request the token and then grant it to the application or the user or whatnot. Tokens always have an expiration limit. At max, they can run for 36 hours. Typically, it's younger, it's small, less time than that. The lowest default is 15 minutes, as it states there. So these can be used to, for example, to sign API requests, pass the token as an additional parameter. So if you programmatically, if you need to pass information, a token in, this is how you get a token: is you query the STS service. Now, IAM out of the box does not support, has an application user database, nor does it support logging into an operating system. People have extended it to work for an operating system, and AWS has extended it to log into RDBMSs to databases. But officially, there's no support for that for operating system or application users. So it's really just for AWS infrastructure. So one thing to note here is that, or the main takeaway is that IAM is a super powerful service to authenticate and authorize users, right? It mainly focuses on these three entities: groups, users, and roles. But you can federate that. By the way, when you federate, you typically grant role permissions, like temporary permissions, to the users on the other side of the federation, like, for example, Active Directory users and groups, right? You for the console, you'll need a username and password. For every other type of access, you'll typically need an access key and a secret access key. And remember that policies are just collections of permissions. Some of the best practices here is that don't use the root keys. I actually have had a company go out of business. It was about 10 years ago. Is that right? 8 or 9 years ago, because someone went in and the root key for the AWS account was, again, that, by the way, that's a production key that has access to everything, was copied into a GitHub repo and was hard coded into an application, and it was left there for years. And by the time I got there, someone had deleted the non-production infrastructure, and the company was out of business within 6 months. They never recovered from the loss of their non-production infrastructure, much less their production infrastructure. So make sure you don't use root access keys against the owner account. Make sure you create IAM users that are accountable, like associated with one and only one user, or one and only one application, or one and only one service. So that way you can have some level of accountability. Make sure you follow the rule of least permissions. So you grant least privilege there, as far as making sure that they only have exactly and just enough of what they need. A lot of people will try to use managed customer policies with groups instead of using inline policies that are attached to users. And make sure you've got a decent password policy, as appropriate. And then make sure the MFA is enabled as a policy by default in your account. There's a few other things to think about, such as making sure that you use roles for applications that are running on AWS. So don't assign secret and access keys to those applications. Try to use roles to delegate permissions instead of getting someone permanent permissions. So it allows them to elevate to a new like role instead of just having access as a general rule of thumb. Obviously, you want to police your user database as much as possible. Use policy conditions. You know, if like the source IP address is outside of your corporate network or outside of your VPN, should they have access to the service in question? I don't know, food for thought. And of course, monitoring activity in your account as a whole is a really good practice, really good idea to follow. On that note about monitoring activity, and since we are in the security section, it would be completely remiss if we didn't actually just at least mention that there's a service called CloudTrail that will literally track every API call made against your account. It won't track what happens inside of an operating system, but if someone decides to go in and stop a virtual machine, it'll track who made the call, when, where, who, what, and why. Well, we'll get why, but it'll get everything else. It will either put log files in an S3 bucket, or you can put it in CloudWatch logs, and then you can like parse it and look for it if you want to. It usually takes about 15 minutes for an event at most to make it over to CloudTrail. But if this isn't turned on in your account, you definitely want it turned on. Good. Any questions about the shared responsibility model, about just users, groups, and roles in general, or even about like CloudTrail?
Is CloudTrail like an opt-in chargeable per log service, or is
Oh,
it
yeah.
something enabled by default?
Yeah, no, that's a good question. Actually, it is a chargeable service. The IAM is free, so that's probably worth saying. Is that user management and all that's free, but if we go into CloudTrail, it's actually going to charge you not only for CloudTrail itself, but it's going to charge you for the storage of the log files that are in the S3 bucket. Now, again, relatively cheap, but as you can imagine, that can add up to some significant costs, especially if you have multiple accounts. But like here, I've got everything logged right now, and my account, because it's a demo account, it's not super busy, but it is charging me like pennies, you know, per month with just zero activity practically.
It's pennies per month and pennies per entry.
Yeah, it's like fractions of a penny per, like 0.00009 or something like that. It's super low. Yeah.
Okay.
But as you can imagine, more activity means more logged calls, meaning more log. So you're getting charged both on the S3 side and the call side. Is it worth it? Absolutely. But, you know, do know that, like, you know, you might be judicious about recording every single thing if you've got some areas locked down inside of your account.
Sure.
Yeah. So notice, by the way, it saw that I just entered and exited a role. So if we look, you can actually see that I actually was, I was in US East 1 apparently, and I switched my username. Here's the actual event. I assumed the role of Forrester admin, right, from Spartan Sage. They actually captured like what my user agent was and other pieces. So this is kind of detail that CloudTrail gives you. Other questions? Okay, let's do a little knowledge check. If we were in person, I would give you stickers and other awesome prizes, because, you know, who doesn't want stickers on their laptop? Just kidding. Not everybody does, actually. But we're just gonna have to score for imaginary points actually today. So a web application must read, write a DynamoDB table and an S3 bucket. This operation requires credentials and authorization. What IAM entity should be used for a web application? My question would be, and just so you know, this is supposed to be on EC2. So it's on AWS infrastructure. What would be AWS's recommendation as far as what IAM entity to use for this?
Role.
That's right. If it's on AWS infrastructure, don't give it a username and password or a secret key access key. Give it a role. So that's the right answer. Good. Let's see. I did my demo already while I was poking around. Someone's seen that. Good. While I'm transitioning, if there's any other questions, go ahead and voice them. Otherwise, we're going to talk about databases. We actually do have a lab. Oh, look, there's my little quick labs number. We actually do have a lab for this one. So I'm going to go ahead and pre-warm your lab so you don't have to wait for them to start. Let's see, we're going to spend about 45 minutes talking about databases, and then we're going to combine a break, hopefully, with you doing the lab. The lab's about 30 minutes, and so we're going to make it 45 just to make sure that you can squeeze in a break as needed for this midday. But let's talk about data stores. Okay, so we want to understand, some of the different models, like just quick SQL versus no SQL, RDS concepts, and some DynamoDB concepts. Amazon has done some really cool things with DynamoDB, but also with Aurora, which is a subflavor of RDS, including a serverless option, which is the first version was just honestly just hot garbage, and the second one is amazing. So the first version they came out with was just not great from a performance value standpoint. But the second version they came out with is not hot garbage. It's actually really awesome. So we'll skim some of those details, but just know that they are driving serverless databases, which you only pay for if there's a query run against the database. That kind of turns in my brain the whole run a server, stick a database on it, and then pay for that server the entire time model. Kind of blows that aside to a certain degree, which is what I'm used to. So we'll talk about that. So let's talk about RDS and DynamoDB. So the first thing to note is that, typically when we're talking about SQL, we're talking about tables that have rows and columns, a higher degree of what they call acidity, right? Atomicity, consistency, idempotency, and durability, right? All the things that make contention in a RDBMS awesome, because this is why we make these databases our systems of truth, our systems of record, right? It's because they resolve conflict really well, and they're strongly consistent. If two things are trying to write to a database at the same time, they're going to go in order, right? And you don't have to worry about replication because there aren't multiple systems of truth in a traditional SQL-based system. There's one writer, one, and that machine is king typically. Now, don't get me wrong, you can get clustering going and stuff like that and have multiple writers and get that happening both from any of the enterprise databases in particular. But typically, like, scalability is not of high concern. Consistency is more of a concern when it comes to most SQL-based systems. And they usually scale by upsizing the system or offloading reads onto a read writer. And they typically will use a structured query language to query against a relatively fixed schema. No SQL, which means not only SQL, doesn't mean not SQL, is basically a key value store. And this is like blobs of data that are usually just structured in some form or fashion, usually like JSON. And the schema is dynamic, so you can actually add fields and attributes to that blob of data as you see fit, as long as it's in a key value format that can actually be parsed. It usually focuses on a collection of documents. These systems usually cluster out of the box, so they are used to horizontal scaling, but they're not strongly consistent typically. Typically, they're eventually consistent, which means that multiple writes can come in at the same time, and they kind of have to be resolved, right, depending on what system the NoSQL cluster is using. You can see on the left the more structured kind of SQL structure, and on the right, the more blobby NoSQL, retrieval of data. So when it comes to database technologies, there really is no one size fits all. It really depends on your use case. But companies tend to rely on the same 3 or 4 core technologies. They'll usually have an RDBMS, like an MS SQL or an Oracle, which is totally fine. Then they might have some kind of NoSQL system, like a MongoDB or a Cassandra. And then they'll probably have a search system, like an Elasticsearch typically now, maybe Solr, if they've been doing it for a while. And then, if they need social graphing of some type, like a graph database, they'll use like a Neo4j database. Amazon has all of those, by the way. So it really just depends on your format, the data size, the frequency. So just know that Amazon has almost all of the popular database technologies out there as a service. Now, you can see here, there are a ton of services here. We've got the relational database service, we've got DynamoDB, we've got Elasticache. Most of these, by the way, are code for just open source analogs. For example, Amazon Neptune is just code for Neo4j. DocumentDB at the very bottom is a MongoDB compatible database. If Keystore was here, that's just a keyword for Cassandra. So just know that most of these, like maybe with 2 or 3 exceptions, are actually just open source analogs. They're just copies of open source databases in a sense, with all of the cloud and Amazon goodness that they could throw in there. So don't get me wrong, it's not 100% equivalency because they've converted it for cloud usage. So there are a bunch of managed database services. And notice that Elasticsearch also isn't listed here. Neither is Solar, which is Cloud Search, right? So we're going to talk about 2 of these services. RDS is the first one. So RDS is really just a relational database service, but there's a flavor of RDS called Aurora that is purpose-built for cloud. It doesn't run based on virtual machines per se. It uses a slightly different model. So right now, the engines supported are Microsoft SQL Server, right? Oracle, MySQL, MariaDB, and Postgres. So MS SQL, Oracle, MySQL, MariaDB or MariaDB, depending how you want to say it, and then Postgres are the 5 different flavors. Aurora, which is listed there as if it's a flavor, is not really a flavor. It's kind of a subset of MySQL and Postgres. So just know that Aurora is really just a cloud-enabled version of Postgres and MySQL that Amazon wrote. Now, RDS is deployable on VMware. You can actually deploy it as a virtual machine. And it will hook back into AWS infrastructure. So this is simple to deploy. Now, you may remember earlier, just to talk about deployments as an example, when we were at ec2instances.info, one of the things I want to point out is that there was this RDS tab on the upper right-hand side. That's because RDS uses these EC2-like virtual machines to create database instances. So you might create a test database. You might want a T3 instance, which is a test instance from my perspective. You might use that. You might have a RAM instance that you might want to use, like an R5. And so you might actually look at the R5 series because you want a high ratio of memory to CPU. So notice this is 2 CPUs and 16 gigs of RAM. So 8-to-1 in the ratio. So just note that ec2instances.info that I showed you earlier, which is also instances.vantage.sh because that just got bought and redirected. There's 2 tabs here, one for EC2 and one for RDS. So be aware, like there's stuff here for RDS as well. So RDS actually uses virtual machines underneath has a deployment unit for these RDS SQL engines. Note that Aurora can also use serverless, which is a very different beast than using virtual machines. So this works exactly like it does on premise. If you run Oracle out on RDS, it works exactly the same as it does on premise. The only distinction is that if you need to do some kind of kernel customization or log into the operating system, you cannot log into the operating system for RDS. That's all governed and managed by Amazon. So this means, by the way, that they're responsible for patching and everything else of the system, and they do a good job of it. So that when they talk about DB instances, they're talking about these EC2 virtual machines that are purpose-built for databases for RDS. So just know that the whole tab that we were looking at, those are all database instances that we were looking at just now. Now note that you can take backups, usually up to 35 days automatically. You can also take manual backups with RDS. You can also spawn databases off of your backups if you want to, and you can actually create reader databases off of your live production database just with a click. So if you want a reader database, like just for reading or reporting, that's 10 times the size of your production database, you can spin that up and then delete it as soon as the reporting is done. You can also, by the way, spin those reader databases that are associated with the primary out to other regions. So if you want to put a backup live over into another region, as long as it's the same size or larger as your existing database, it's going to run great. There might be some replication lag if you go too far around the globe, but just know that you can actually spin a reader up into another physical location if you want to. Please note that if you use the automated backups and you delete a database, it's going to ask you, do you want to take one final backup before I delete all of your automated backups? So just be careful. You want a manual backup process in here as well as the automated process, meaning manual in the terms of like it can be automated, but it's one that you've created, right? Because if you use the automated system and the database, you delete the database, it deletes all the automated backups as well, but not the ones that you've automated outside of RDS. These are also stored in a hidden section of S3, right, for this your purpose as well, just like the EBS snapshots are. So, yeah. Oh, you can do cross-region snapshots as well. That's right. This was announced actually a couple of weeks back. You can actually take a copy of a database snapshot stored in one region and actually copy it for DR purposes in another region. So it can be used as a base to launch a new instance, or if you're wanting to avoid like network bandwidth, you can actually just take a backup, then copy it to a new region, and then stand up the new one, and then just do a differential against the previous database. So RDS, by the way, is typically not exposed to the internet. You can control access to RDS using IAM policies. It will have a firewall around it, so you get to control who can get into that system, not just through the SQL engine itself, but also prevent it through the firewall. You can turn on transparent data encryption for MS SQL and Oracle. You can also enable and force network encryption as well for all of the databases actually. And so you can use the security features of your database engine to control access to the instance as well. So there's a lot of security options. Here's a simple architecture. You've got an application load balancer, which is distributing traffic down to those orange, yellow, red, sorry, not yellow, orange, red boxes for EC2 applications. They in turn are talking to an Amazon RDS instance, which in turn is writing backups out to snapshots are happening to a DB section of S3. Note that you can also chain those security groups together so that the database will only accept database connections from members of the EC2 application server group, and that the application server group is already set up to only accept connections from the application load balancer. With a checkbox, by the way, you can create a primary secondary situation with two database instances. They will be the same size. You cannot talk to the second instance or do anything with it other than fail over to it. And failover happens automatically with RDS. What that means is that if the first instance hiccups or fails for any reason or is rebooted, what happens is automatically Amazon will change the DNS name that they gave you, and they will change the underlying IP address to the second instance. And the username and password are the same because it's been replicating with the primary. So what happens is that with a multi-AZ deployment, failover happens automatically based on DNS names. It usually takes a couple seconds, sometimes half a second, sometimes 30 seconds, just depends on the nature of your database and application. But it will automatically fail things over, and then the application can just pick it up as soon as it comes back online. When it needs to patch a system, the first thing it's going to do is it's going to apply any planned maintenance first to the standby database, bring it back up as the primary, and then it's going to do database maintenance now against what was formerly the primary, which is now the secondary. And it's just going to leave them, by the way, that way. It's not going to revert them back because they're both the same size. They're both the same box. Note that when you check that box for multi-AZ, you now have a primary database in one availability zone, and now you have a database in another availability zone. You can control where that goes, but they will not be in the same availability zone in case one of the availability zones goes down. Here's a little bit more of a durable architecture compared to what we were looking at before, which is pretty simple. Notice in this case that, the EC2 instances are larger. I don't know why. But they're all pointing to that primary DNS name, the C name, down to the Amazon RDS primary. In the event that there's a failure, they'll automatically get redirected through DNS over to the secondary. Here's a couple of best practices. One, it is probably a part of your application, so you obviously want to monitor it, right? Try to use multi-AZ because that's considered best practice with Amazon, is just to make sure that you're using 2 availability zones. That way also you can suffer reboots and resiliency. So this is a way to solve the reboot problem that we were talking about earlier, is that you can actually get it so that it will actually reboot if necessary. And it won't cause an outage, it'll just fail over. Actually, I say that it could cause a couple of seconds of outage, which actually could be significant, but it'll lessen the time to resolution for the outage. Make sure you enable automated backups and that you actually have enabled your own separate from that system, like once a month or once every 2 weeks or whatever, automated backup as well. That way you can retain backups over time for systems. Storage is cheap for S3 for this. Make sure that your backup and maintenance window is occurring during a low work period for your operating system. So when they patch this for you, they ask you, they're like, when is a good maintenance window by which we can do this? And then you want to make sure that the TTL for your CNAME or whatnot is set pretty low. If you are on the client side, if you're like using another DNS resolution, make sure that your time to live for those records is set pretty low. So if it does fail over, it'll actually get a refreshed copy of the IP address and DNS resolution. And that's pretty much RDS in a nutshell. Any questions about RDS and running like an MS SQL server, Oracle, anything along those lines? Okay. Well, then let's talk about AWS's flagship DynamoDB system. So if RDS is just your traditional RDBMSs that we know and love, DynamoDB is actually based on a Dynamo paper that was actually written, I think, in like 2001. There is actually an open source equivalent for DynamoDB. It's called RIAK, R-I-A-K. It was written in Erlang. I've actually supported it one time. Wanted to pull my teeth out. It's really a tough database to deal with. The managed version of it is amazing. So this is what DynamoDB is. So DynamoDB is like S3 in the sense that Amazon will tell you can store whatever amount of data you want out there. Each row, I believe, is capped. I want to say 256K. So you're not going to store like large swaths of data or binary objects out there. It is SSD backed, so you can get microsecond response times off of DynamoDB, meaning you'll run literally into TCP/IP limits before, like in terms of performance. It's ridiculous. This is a NoSQL system, so it does work off the concept of tables, but there's no servers. You're not messing with servers anymore. You create a table, it creates the table for you. You tell the performance characteristics of the table, and then you just start sticking data in there. And then you can actually set performance to be on demand. So it scales up and down as you need to in response to your queries. The data model is NoSQL, so it's like schemaless. But typically what happens is you'll create the table, then you'll have rows or basically items inside of that table. And those items will have attributes that are basically just name value pairs. Like it's a key, like artist, and then that will have a value like Prince or, Van Halen or whatever, right? Bach, if you're looking for that, right? And then what will happen is that you'll actually usually set one of these has like the partition key basically that you want to use in the system to kind of search against that key. So it's like searching against artist would probably be a pretty great key. Song name might be a great key. A combination of artist and song name is probably a really good unique key to get access to songs. So when you specify that primary key, you can also do with two attributes. That's called a composite key, right? So just know that, you know, there's the partition key. You can also have a sort key, but it's like a composite like key, if you will. So there's the partition key. There's the sort key. DynamoDB is going to maintain a sorted index for both of the keys. And that, by the way, makes it a composite, right? So you can actually search on both attributes. Now, there's a couple of different modes, mainly provision mode and on-demand mode. So basically in provision mode, you're like, hi, I want 20 reads per second and 10 writes per second. In on-demand mode, you're like, hey, Amazon, just do whatever it takes, right? And you're like, just give it whatever it needs. So if someone comes in and says, hey, I want 1,000 reads per second, you got that, right? Yeah. So just know that a read capacity unit, if you set like in provision modes, is 4K. Oh, that's right. So that's what the limit is. That's right. It's a 4K limit size. So just know that when you go in and pull that 4K data out, that eats one capacity unit. So if you ask for 1K of data, it's going to eat one capacity unit. If you ask for 8K of data, it's going to pull 2 because they're at 4 in terms of size. So just remember there are 4K chunk sizes when you copy data in and out of DynamoDB. That's for reads. For writes, it's 1K chunk sizes. So when you say, hey, I want to have 1,000 write capacity units, you can write basically 1,000 kilobytes a second into the system. Most people use on-demand mode, so they don't have to deal with turning the dials on performance. Because if you're in provision mode and you say, look, I'm only going to support 20 reads a second, and someone comes in and does 40, half of those reads will get a provision throughput exception error, and they'll be told that they can't be provisioned right now. Try back again in just a second. So just know that DynamoDB has different modes of capacity and performance inside the system. Most people use on-demand. You can query, you can scan a table. Obviously, queries are more efficient because scan requires you to read the entire table. You can even filter, obviously, either scans or queries once you get data back. Queries are by far more efficient because they're very targeted, right? And you do have the concept of indexes in DynamoDB, which are basically in-memory caches, right, that you have of the data in question. So know that you can actually create local and global indexes inside of DynamoDB. And you can also do conditional expressions when you do your query and scan operations. Here we've got a simple application architecture. We have a load balancer distributing to a couple of apps, and they in turn are talking to a DynamoDB database. To give you a sense of the scale of this system, of a DynamoDB box, a single table, I think it was in Prime Day 2019, handled 10 trillion writes a second. No, was it writes a second? Yeah, I think it was writes a second. It's like 10 trillion writes a second. It was something ridiculous. So this is a way super performant database system, which is great for high volume throughput. And even at like lower levels, because most of us are not operating at that scale, it is super performant. But if you need strong consistency, you can actually enable DynamoDB to be strongly consistent, but it will not have the acidity of an RDS database. But you'd be surprised at the number of use cases that actually don't require acidity to actually function. So the main takeaway here is that, you know, if you have existing database apps and you need SQL and you're used to that technology and your toolings for that technology, you probably want to use RDS. If you want something that's a little bit more, for lack of a better word, web scale, which I don't necessarily agree with, but it's like cloud native, cloud scale applications with a large number of changes, large number of small reads and writes, NoSQL is going to be your friend. But if you need, schema, strong, acidity, strong consistency, you're going to stick with RDS. If you want something a little looser, you're going to go for DynamoDB. I think those are pretty self-evident. If you need a relational database, you're going to go to RDS. If you need a fast, scalable NoSQL service, you go to DynamoDB. If you want to manage a database on your own because you need custom modifications or kernels that are not supported by either RDS or DynamoDB, well, then you're going to spin up your own EC2 instance. Good. Any questions about DynamoDB before we move forward into a little knowledge check? Good. Okay. Let's check this out then. So what are the basic building blocks of an Amazon relational database service? What is the basic unit of deployment? It was actually a tab on a website. Do we deploy, is RDS serverless? Do we deploy them in containers, or are they deployed into virtual machines? Yeah, it actually is an instance, right? So in this case, it actually is a database instance, which is basically just an EC2 virtual machine. That's all it is. Remember, over here, we were on the RDS tab, and we were looking at basically what looked exactly like virtual machines. That's all they were. So database instances are nothing more than just virtual machines. They're just repurposed. Good. Question 2. A customer is creating a resilient, durable application using Amazon RDS. In addition to Amazon RDS automated backups, which feature should the customer use to make sure that their backups are durably retained? What kind of snapshot did I say you should also take? Ooh, sounded like someone was going to hop in there. So if I have automated backups, remember I said that to occasionally take a manual snapshot as well, just to make sure, right, that because the automated backups are associated with the RDS instance and they can be deleted if the RDS instance itself is deleted. But manual backups ensures that you have a backup of that that's outside of that scope and cycle in case you need other checkpoints. Number 3, DynamoDB allows customers to store any amount of data with no limits. That sounds a little bit like a marketing question, doesn't it?
It's true.
It's true. They do. They don't have any limits. Just like S3, they're not attached. As much as you want to put data in there, they'll take it. Okay, so out of querying and scanning is the most efficient way to retrieve items from a DynamoDB table. Is that true? Is that true in like to scan an entire table is more efficient to query a specific item?
That would seem false.
Right. I mean, that's true for almost any database system I've ever seen. Asking for something specific, particularly if there's an index or a way to find it, tends to be more specific than just a broad scan. Good. All right, so we're on to lab 2, where we're going to spend, I think we said it was 30 minutes, but we're going to add a little bit to it just to make sure we get a little bit of afternoon break. we're going to create a database server, create a security group, create what's called a DB subnet group, which allows you to determine where your databases are going to live. Then you're going to create an RDS instance, get the database connection string, and then open it from a web browser. Notice it says, while waiting for the database to start, go take a break. That's basically what it says. So I'm going to encourage you to take a short break after you've started the database. And then you're going to see records populate in your system. So if we go take a look at webage.quicklabs.com and we go to our second one, I note that there are at least 10 pre-warmed labs here. That's awesome. If I open the lab, just notice the instructions are the same. Security group, DB subnet group, RDS instance, and then test it. That's it. So we're going to be working on lab 2 for AWS Technical Essentials today. So I highly recommend that we go ahead and hit the start button and get started. Remember that you want to be put on your detail orientation glasses. Make sure you're like reading with the steps. Note that these interfaces do frequently change. So just make sure that you're, reading everything in detail. All right, we'll go to it. So, I'm going to be here hanging out, although I might step away for about 5 minutes. Let's say that we're going to run until 20 minutes after 3. That's probably what we're looking for. Okay. All right. Otherwise, let's go conquer lab 2.